There we go. Okay, so I'm very glad that you've just joined, John, because as usual, I like to start by asking what the STEAMettes have been up to. I'm guessing they're on holiday at the moment.
They are, yes. Enjoying their last week before they start their new schools.
Oh, are they all just going up to the
whatever, yeah.
Wow, a big jump for them then.
It will be, yes.
Okay.
Hopefully they'll keep up the STEAM club.
Mm-hmm.
But they'll have lots more homework and stuff.
Maybe win some new recruits.
Well, yeah.
Yeah. So I think last month you mentioned that they were involved in a large radio event.
Yes.
I've got a feeling that Matt might be talking about that later, perhaps.
Probably not. No, it's it took place in Los Angeles.
Oh wow! Okay.
Yeah, online, of course, and there were lots of presentations about various aspects of amateur radio, and the girls had done a video, which we saw last time, didn't we? You remember?
Yeah.
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 I had to add to it because they wanted a 20-minute video, so I had to put in my own stuff about what they've been doing and about the BBC microbit. So that went well, and they made a contact with a school in America. So hopefully that will lead to interesting things.
Yeah.
Right, last weekend they took part in their first special event radio station, which Matt would explain. It was their first one, and they made some contacts with Morse Code and with their voice speaking.
Excellent.
Mm.
Very good. Very good. And where were the people? Where were their contacts?
In the Czech Republic.
Okay.
Yeah, that was on Morse. Yeah, this chap, they put out what's called a CQ, and he came back in Morse. And unfortunately, we had someone there to help us translate his call sign. But yeah.
So do you have to translate from Morse to Czech to English?
These ham operators, they speak brilliant English. They're very good. And so we finished off with 88 in Morse code.
That's
What's
like
88?
I'd have no idea. Anyone else?
Love and kisses.
Oh, is it? Okay.
Yes. Right.
Is that a youth thing or a radio thing?
That's a radio thing.
Okay. Okay.
Yeah.
So they've been very busy for the past month and
yes.
Now preparing for school.
Yeah, and coming up in September, the Radio Society of Great Britain are coming down to Broadstairs to film them.
Wow.
Yeah.
Oh, they're famous.
So that's
over and over again.
They'll be very famous. And they'll be in another convention, and this will be the RSGB one in October.
Yet again, I'm astounded by everything that you do with them and for them, John. It's great.
It's amazing, yeah.
Yeah, and hopefully they will get some more recruits from them. Are they all going to the same schools?
No, some going to Clarendon and Chatham House, one going to St George's, and one going to Roger Manwood.
Ah, so they're dispersing like three seeds on the wind.
Indeed, yes, yeah. And hopefully they'll get their call sign soon.
Okay.
They're training hard for that. Not easy.
Well, they've got lots of persistence and a lot of enthusiasm, haven't they?
Yeah, yeah. I'm sure they'll pass, but it'll take a bit of study for them.
Yeah.
It's not a walk in the park, is it, Matt? Yeah.
Okay, well, thanks for that. Sorry?
In America, they get given the questions beforehand.
Oh, the low standards over there, aren't they?
Well, it's more rigorous, so you know it's tougher, but they do know what's coming.
Well, if in the wild, when they're using their radios, that's probably not the case, is it?
What's that?
Knowing what's coming and how to
I mean, the questions in the exam,
yeah,
they're all provided beforehand.
and that's and they don't know what the questions are going to be in the UK at all.
No.
Well, good for them.
Yeah. Okay.
Yeah, well, thanks for that. Look forward to more news from them next month.
Yeah, in September. Yeah.
Okay, cool. Right. So there's a bit of a preview of the mystery object. Accidentally, I hope no one saw that. The Geekery's news. There's only a little bit of news, I suppose, but we've had some interesting someone wanting to rent one of the desks, which hopefully will come to pass next week, which means there will be only 2 desks left for rent in here. But we'll see how that's developing. But that's really all the news about the Geekery. But I suppose I put this on here to make me make some news for next month, maybe. We'll see. Okay, so I'm going to move on to the mystery item now. So hold on to your hats. This is my second favourite part of the night, third part after the speaker and after the STEAMette. So this is the mystery item. If you subscribed to the Geekery website, you would have seen this already. And this seems obvious if you know what it is, but the first time I saw one of these, it was my chief engineer coming up and saying to everyone, "Do you know what this is?" And I didn't know what it was. So it's kind of burnt into my brain as an object that everyone must need to know. So I'm not going to reveal the answer, but I will answer some questions in a slightly cryptic way, if depending on the question. So, any questions about this? Or these? The number of them isn't particularly relevant.
What are they made from, Matt? Is it rubber?
The black bit is rubber.
Yeah. There's some kind of vibration mounting.
I would definitely put that on the list of options, yes. I'm being cryptic now.
Like a damper.
Okay, cool. Yeah, there was a question in chat. Oh, there's 3 things in chat. Awesome. Okay. Right. I'm going to move on from that. This is where we hand over to Matt, and who's here in the Geekery just over there. Hello. And Matt is going to talk to us about experimenting with Airwaves. And as usual, I won't introduce him. I'll let Matt introduce himself and get on with the speech, the talk. So thank you very much, Matt.
There we go. That should be me unmuted. Let's hope we don't get any audio feedback from that. Would you touch your volume down a little bit for me, Matt? Okay, super. Thank you. Fantastic. Okay, so as Matt said, I'm another Matt, and I am I guess I'm a hardware and software tinkerer, as put up on the screen there by Matt. I'm also a trained commercial RF engineer, and spent quite a lot of my earlier years climbing up masts and playing with RF and everything radio. I spent some time working for various commercial organisations, and I spent some time with the Kent Police Force as well, managing communication infrastructure across Kent So I naturally like all things radio, and that kind of led me into the hobby of amateur radio, which I'm going to talk about today with you. Let me just see if I can share the screen here. Let's, I think we want to be sharing that. And then I think we want to pop into there. How's that? Is that looking good?
Yeah.
Super, excellent. So first off, a quick apology. I've volunteered to do a talk at very short notice. So I had a chat with my friend Simon, who's given me these slides to go through with you. So this was prepared by a chap called Simon, and the letters after his name there, the M0LMK is his amateur radio call sign. And it is presented by myself, Matt, and my call sign is Mike 0 Lima Mike Kilo M0LMK. And I've also got a second call sign, which is KI5GXV, which is an American, a US license as well. So I hold an amateur radio license for the UK, and I hold a separate one for America. And regardless of what John says about them being easy and having your questions beforehand, it was still relatively tough. So excellent. So what is amateur radio? Amateur radio is basically a technical hobby. There are hundreds of thousands of people all over the world. I think last count in the UK, just over 80,000, just over 80,000, I think, in the UK alone, who hold licenses. And it is an international community. So no matter which country you're in, maybe bar North Korea, you can become a radio amateur and you can hold a license. And why that's important and why that's an interesting thing is as radio amateurs, we are the only group of people that are allowed to experiment with unlicensed equipment on a huge portion of the radio frequency spectrum. So we can develop and play and fiddle and do whatever we like there without having to apply for expensive research permits or things like that. The only minor kind of setback from that is you can't do anything for commercial gain as part of that license. So you can develop something and then take it away and sell it commercially, but you can't use the radio spectrum to provide a commercial kind of service. So so it's for experimentation and kind of playing only, effectively. But still, we're very privileged to have that ability to do that, because there's no one else in the world that can do that. Even large companies, you know, they have to pay huge amounts of money for research licenses and permits to be able to get on and experiment. So what do we do with all this mighty power and trust that's invested in us? Well, we bounce signals off amateur radio satellites. We talk to astronauts on the space station occasionally. We develop all sorts of radio control things, and we can control lots and lots of different equipment and infrastructure via radio. We don't just talk and send Morse code. We have a huge variety of digital modes available to us where we can transmit data, high-speed data, low-speed data. We can send pictures. We can send video formats. So we can also do the old school stuff. So we can do a bit of Morse code, which is quite good fun as well, if you like looking back at history and having a go with that. And all these different modes and things have different benefits and drawbacks. We can build our own equipment, which again is something that most people can't do. So we can make our own equipment and put that equipment on air. And we can restore old equipment and use that as well. So we can do lots of different things. And just down the bottom there on that slide, Simon is telling us that there's all these different things. QRP, which is low power, HF, high frequency radio, a bit like shortwave. VHF, very high frequency. That's kind of in the territory of your FM radio that you might receive at home, listening to the local radio station. Dxing, so that's where we're talking long distance. We're trying to get as far away as possible. ECOM, which is emergency communications. Lots of technical stuff we can do. Contesting, exactly that, competitions. And then we've got satellite, digital, TV, and space communications. So quite a lot of things that we can do with our licenses. So here's a little bit about what it is. So amateur radio is a regulated but non-commercial radio service. I think we covered that. One of the nice things is that in the UK, when you have a full license, and we'll look at the license levels in a bit, but when you're fully licensed, you can use up to 400 watts of RF power. And to put that into perspective, your mobile phone will typically use between 1 and 2 watts. Most standard mobile phone base stations around 50 to 150 kind of watts of output. A walkie-talkie type thing that you might buy at Argos, about 500 milliwatts, about half a watt. So as a licensed amateur, you can use 400 watts in the UK, which is it's a lot of power, and there's a lot of potential for fun and games with it. Experimentations, again, not only allowed but actively encouraged. It's about getting in and actually having a play with things, understanding how things work, breaking things, occasionally letting the magic smoke escape. So all good fun to get involved in and get your fingers dirty. And we talk to people all over the world, not just locally, and we exchange all sorts of things, usually the weather. But there's lots of technical groups that you can talk to. You'll always find someone that's interested in something that you're doing, and there's lots of kind of subgroups and kind of mini forums. So think of it as kind of a Facebook, but without Facebook. And like I said, there's something for everyone in the hobby. There's over 80,000 licensed amateurs in the UK, and our ranks are growing despite the internet and social media and things. We get more and more licensed amateurs every year. So I think Simon's going to show us a few little things here. QRP, I touched on that. So QRP is a method of operating where you use as little power as possible. So you might have a solar powered system, a radio that's powered by a battery and a small solar panel. And these guys often climb up the top of mountain tops to get the best locations and use as little power as possible. And they measure it in something along the lines of watts per mile. So they measure how far the distance is they've managed to talk, and they calculate how much power they needed to talk that distance, and they work out, it was 0.017 watts per mile they managed to use. So that's just one of the facets of the hobby. On the other side of that, you've got something called QRO, which is high power, and those guys will use as much power as they possibly can to talk to the guy just down the road. So there's two extremes of the hobby. Part of the hobby is HF radio, high frequency. So these are radio waves that live down the bottom end of the radio spectrum. They're often called short waves. And these radio waves can travel thousands and thousands of miles, and they bounce off the ionosphere that surrounds the Earth. And at different times of day, the ionosphere will react differently. So different frequencies of radio waves will pass through, others will bounce off. Some will hit and scatter in all sorts of directions. Others will hit and kind of bounce off a bit like throwing a ball against the floor and carry on its merry way around the globe. Here's another slide on propagation, just showing you that the transmitter there is sending a wave up, if you like. It's bouncing off the ionosphere and coming down. So it enables you to talk to people that are beyond the curve of the Earth. And kind of the distances that you'd kind of expect is you can usually, from the UK on a normal day, you can usually hit the east coast of the USA and all over Europe. And when there is good propagation, when the ionosphere is playing nicely for us, you can have a conversation with someone in New Zealand or Australia or west coast of USA as if they're standing in the same room as you. So we get very good quality communications when the ionosphere is playing nicely for us. The other thing that affects our communication is solar waves from the sun. So when the sun does a coronal mass ejection and it fires these particles towards the Earth, they positively charge the ionosphere and the various layers of the Earth, and that can affect our communication as well. And interestingly, they can also cause things called Carrigan events. I'm not sure if anyone's come across those before, but that's basically they can cause so much interference that they can actually knock out communication systems. And we had one happen here a long time ago, and it set fire to overhead wires carrying electricity and all sorts of weird and wonderful things, and effectively knocked out a lot of communications. So the sun can play a big part in how we talk to people and how we communicate. This is maybe a bit more in-depth slide about the ionosphere and the different layers and how they interact, etc., etc. I'll just leave that out for a few seconds, but it's not really what we want to delve into. It's a bit more of the technical stuff that we don't really want to cover. But as you can see, you can get quite in-depth with this. And I think there's some meteors on there as well. Yep, so we can bounce our signal off meteor showers, for an example. There's the aurora on there, the northern lights. And again, that can affect the way that our signals travel through the atmosphere. And then you have the troposphere as well. And again, that can affect the way our signals travel through the atmosphere. So all these different things can affect the way that our radio signals move and behave. I've got a UK band plan, but I don't think there it is. It's come up yet. So this is an example of the frequencies that we have access to. So you've got at the very top there a band that we call 160 meters, and that is the physical wavelength of the radio wave. So if you were to be able to see the radio waves as they travel through the air, that 160 meters is a full cycle of the radio wave. So it moves like a sine wave, goes up, comes down, goes past the negative, comes back up again, and that's one cycle. So one cycle of that radio wave would be 160 meters long. And as we move up in frequency, as anyone who has ever maybe if you've ever grabbed a rope and given it a shake, the quicker you shake it, the smaller the waves are that travel down the rope. So that's the higher the frequency. So the higher the frequency, the higher you shake, the faster you shake, the smaller those waves are. And that's the same thing happens with radio. The higher the frequency, the smaller the waves get. So as you can see, we go up to kind of 50 megahertz kind of territory, and our waves are now only 6 meters long. And then we start going up to 23 centimeters, which is 1.2 gigahertz. So our waves are only 23 centimeters long. So they get smaller and smaller as we go up. And Wi-Fi territory, something we're probably all familiar with, 2.4 gigahertz. The wavelength of 2.4 gigahertz is about 13 centimeters. So that's how we reference bands or chunks of frequency that we're allowed to use. We generally reference them by the wavelength. It's a lot easier than trying to remember, 24.890 megahertz. It's a lot simpler for me anyway. So that's just an example. We have allocations that go all the way from about 200 kilohertz, the wavelength of which is several hundred kilometers long. So I don't think anyone would want an antenna for that in their garden. All the way up, we go past 10 gigahertz, all the way up to 40 gigahertz. And we've got an allocation all the way up at 60 gigahertz as well. So we have lots and lots of these kind of chunks of radio spectrum to play with, as you can see. We touched on HF and how that kind of bounces off the ionosphere, and we can talk to people all over the world on HF and how it's affected by the sun and different atmospheric conditions. And then slightly higher up the frequency spectrum, we have VHF and UHF. Now, this is the kind of frequencies that you would use where you would see people using handheld radios at events and things like that. They'll hire a radio system. They'll be on VHF and UHF kind of frequencies. They're generally line of sight. So if you can see something, you can talk to it using that equipment. Or you can use things called repeaters, which are effectively two radios plugged into each other. And it takes your signal in on one frequency and it spits it back out on another one. And we have several of those around Kent. We have an extensive network in the UK of repeaters. And we have two in Broadstairs, or two in Margate, I should say, which are located on top of Invicta House, which is the big block of flats in Cliftonville. And I actually maintain that equipment up there as well. So that lets us take a small handheld radio, which I've conveniently left on the other side of the room. It lets us take a small handheld radio that can cost anywhere between kind of £30 upwards, which, you'd normally be able to talk to someone the other side of your street or just down the road a little bit with those radios, but with the use of repeaters and infrastructure that's put in place entirely for free, entirely by volunteers, you can talk pretty much kind of, I'd say between kind of 30 and 50 miles off a single repeater, depending on the location. And then we can take those repeaters and we can link them together with wireless data links on one of our microwave allocations and extend their range. So when you talk out, when you use one, voice comes out of 3 or 4 others. And we can also connect those repeaters up to amateur networks that are based over the internet. So we can make them come out of every single repeater in the UK. We can make them come out of every single repeater in the world if we want to annoy everyone. So we can map all those through. It's just like making a telephone call to someone with a radio. So that's VHF and UHF. Not as far, and not as, the distance isn't there the same as HF, but you can add infrastructure and make it longer if you want. The quality is also better generally on VHF, UHF. The voice quality is clearer, and very much like anyone who's used a kind of handheld walkie-talkie will kind of know the voice quality is pretty good on them. There's also a picture of a mobile radio there, which is again a VHF, UHF radio. Typically you'd put that in your car or your house, and it has just a little bit more RF power out the back, and you can plug in bigger antennas, etc. I guess we touch on emergency and other volunteer services. So again, as a licensed amateur, you can join various organisations. The main one in the UK is RAINET, the big yellow symbol down there, and that is the Radio Amateurs Emergency Network. And they have been called in the past. They've been called upon by, I know Kent Police has called them out twice when I was working there. They don't really call them out so much these days because they have other infrastructure in place for emergencies. But if all else fails, there are these voluntary groups out there that specialize in providing emergency communications cover. So, you know, if networks fail, if mobile phones fall over, if there's flooding and you know, you can't use the mobile phone network because the base stations are under 4 foot of water, etc., then RAINET are the organisation that will roll in and facilitate communications for that area. And they do some quite advanced stuff, actually. They're sending video and data and pictures over their amateur networks now. So they're quite an interesting organisation. Emergency preparedness is much bigger in the US. They're a much kind of bigger area to cover, I guess, with a lower population per square meter, per square kilometer. So they tend to do a lot more of that in the US than we do in the UK, but it is a facet to the hobby that's there, so it's worth mentioning. Dxing, and you might have heard John earlier mention that they said CQ on the radio, that they put out a CQ call. And a CQ call is like it's like a general call. So you would pick up a microphone and say CQDX, CQDX. And that basically means I'm looking for a contact who is a long way away. I'm looking for someone who is in the distance. So you get, again, people in the hobby that are interested in that, and they will try and work or try and talk to stations that are thousands of miles away. And they'll also collect these things called QSL cards, which there's a couple of examples down the bottom there. And they're typically postcards that are sent from these stations. So we've got one that was sent from Tango November to Tango in the Republic of Congo. And there's another one there that was sent from the St. Kitts Island Dxpedition. And I'll touch on Dxpeditions in a minute. And there are people in the hobby that will collect those QSL cards as well. So you'll go into people's operating areas in their homes, and you'll find the wall just covered in these cards from all corners of the globe. On the back of those cards will be a signal report, so how the station that you talked to, how they heard you, and they'll often put a personal message on the back for you as well. So they're quite interesting to collect. A lot of that's done digitally these days. So a lot of it is sent via a system called EQSL, which is kind of an electronic postcard system. So you'll often end up talking to someone, you know, you might have a chat with someone in Canada, and then about 30 seconds later, you'll get a ping in your inbox, and it'll be a nice picture of their station or a picture of something local in Canada with a little message from them saying, thank you for the contact. And you can print it out and put it up on your wall if you like. I generally don't tend to do that, but a lot of people do. And, you know, it's another nice little facet to the hobby, really, chasing DX. Another section is called contesting. So we have various kind of sports, I guess they call it in amateur radio. And some of those contests are about talking to as many people as you can in a preset period of time, exchanging a specific set of information, and exchanging that information correctly as well. So it has to be accurate and it has to be fast. So it's a bit like, it's almost like the speed dating of amateur radio, if you like, and you get points based on who you've spoken to, how far away they are, etc., etc. We have quite an active contesting club in Kent. called the Invicta Contesting Group. And they meet up and put up some very big, silly antennas in the middle of fields, running off generators. And they run a contest all weekend. They'll be on the radio 24/7 all weekend, and make as many contacts as they can as possible. And at the end of the year, they'll get a trophy or a certificate, pitted against pretty much everyone else in the world. So again, it's an exciting thing if you like the challenge. It's an interesting part of the hobby, and technically it's very interesting as well, because these stations are trying to put up equipment that is extremely efficient, very good at making contacts and doing what it does. So there are some very, very complicated and very interesting kind of constructions that go on. And a lot of these stations will typically set up and then be taken down again. So they're kind of immediately deployable. You spend 5 or 6 hours putting a whole bunch of metalwork in the air, and then you have to take it all down again at the end of the weekend. So yeah, it's a very technically challenging part of the hobby as well. Digital communications, I guess, another part of the hobby. So not only do we pick the microphone up and talk to people and send Morse code to people, we also do digital communications as well. And there are hundreds and hundreds of different digital modes that we can use to send data over the air. Some of them are derivatives of commercial modes, like RTTY, originally used for a lot of shipping and military use. Some of them are developed especially for amateur radio. Some of them are very fast modes, so you can send pictures and text in a matter of minutes, which is pretty fast over radio. A friend of mine actually was doing some tests last night with one of the digital modes, and he sent the entire text of War and Peace in 45 minutes over the radio. So his radio didn't like it very much. It was quite warm, but you know, that was a particularly fast mode. So War and Peace sent across the radio, across the county of Kent in 45 minutes. So pretty good. And I received that, and it was all there. There was no faults in it or anything. I didn't read it, but there was no there was nothing missing. It was a complete data file when it returned. So we can do modes that are very fast. We can also do modes that are extremely interesting in that you can send data across a system where you can't physically actually hear it, and where that data is actually underneath the noise. So we can't hear it. You wouldn't see it on your screen. As you can see there's some lines coming down that screen, which is a data mode coming down on the right hand side there. So we wouldn't hear it, we wouldn't see it on the screen, but there are several data modes that would actually decode data that we can't physically hear. And if anyone knows anything about signal to noise levels, then one of these particular modes will decode data that is 25 decibels underneath the noise floor. So your noise level is up here. That's what you can hear. That's all the noise, and it's decoding a data mode or a bit of text that's down here underneath that, hidden away. And you might think, well, that's interesting, but what can you use it for? Well, in times where you've got things like electromagnetic interference from the sun or bad propagation from the ionosphere, it means you can still talk to people all over the world, which is quite nice. And you can use it to send data, or you can use it to send any sort of data, text, videos, voice. I wouldn't want to send video on it. It'd probably be a bit slow for video, but it's there, and it's just an example of the kind of depth and breadth of digital modes that we have access to. Very high speed modes, very low speed modes, modes that need a very strong signal to receive, or other modes that don't need any signal to receive. So, you know, a huge, again, another facet of the hobby that has a huge amount of depth to it. Repeaters and internet communication, we kind of touched on this before, where you can install repeater sites on high locations. So our little chap there with the fantastic haircut on his portable radio, he can talk via repeaters to someone the other side of a mountain, for example, where traditionally with his little handheld radio, he'd have no chance of getting through that mountain. So, and again, we can link these things up via the internet, or we can link them up using data links that we provide. We can even link them up with links on different frequencies. So we could link a VHF repeater to another repeater using a UHF interlink. So we can do all sorts with it, all good fun. Morse code, CW, probably all familiar with ... So again, it's still there, still practiced in amateur radio, has a huge following. One of my friends is a very good CW operator. He worked out at sea, and he was the communications officer on board one of the ships for the Icelandic Cod Wars. So his Morse is absolutely spectacular. He's a joy to watch. I've got no idea what he sends. So, but again, it's another kind of facet to the hobby where people can get involved in and enjoy. Slow scan television, I kind of mentioned that we can send pictures, so we can send images and pictures to each other. This particular image that's on the screen here was received from the ISS, from the International Space Station, which has an amateur radio repeater on board. And they put it in various modes. Sometimes they have it in SSTV mode, where they're sending pictures down for us. Other times they have it in voice mode, where we can talk through it, so we can actually send our signals up to the space station. They're rebroadcast back down to cover the footprint of wherever it is. And they also can run it in something called APRS mode, where we can send it positional data and it will repeat that down to everyone else as well. So they do various things with that. But SSTV, you can use that on all the band, all the frequencies we have available. You can use SSTV on, which is quite fun. So you can use it locally, or you can use it to send images around the world.
Do you still have GB3EK?
EK, yeah. So GB3EK is not currently linked up to Echolink. Echolink is one of the networks across the internet that links these bits of infrastructure together. It's an amateur radio network that's provided by amateurs. But GB3EK is the local repeater, which is on Invicta House. And usually it's connected to that network, but at the moment it's disconnected from that network. But only because the actual hardware that does that job is currently very poorly, because somebody decided to set fire to the bins at Invicta House. And in the architect's wisdom, the bin chute ventilates into the tank room where all the drinking water is and where all our equipment is. So they came along about 2 years ago and they had a fire inspection. They thought, I know what we need to do with this tank room with the vented doors on it. We need to seal it all up, so if there's a fire, it won't be fed by oxygen coming into this room. So they fire sealed the room, effectively made it airtight, and then the bin chutes ventilated into there. So it turned it into a massive bin fire smokehouse. So the equipment that was up there is no longer up there. It's currently bathing in a bath of isopropyl alcohol to clean it up. But it will go back up and will be connected back up to the internet at some point. The other repeater we have up there, which is GB7TH, is a digital repeater. So it uses UHF, but it's a digital mode. It's not FM voice, it's a digital voice. And that's connected up, and that's connected up all over the world. So you can dial other repeaters all over the world with that. So yeah, it's a nice little system actually. And that's the handheld that I've brought with me that actually works via that repeater as well. So again, a little handheld radio. You can be talking, sitting in your garden, using your 40-50 pound handheld radio, and you could be chatting with someone who's on the other side of the world quite easily, no problem at all. The other thing that we can do with the ISS, with the International Space Station, is occasionally we can talk to it. Pretty much every astronaut that goes up there from the US or the UK, and I think most Russians and the Chinese as well, they are licensed amateurs. They actually have their amateur radio call sign. And they can use the radios on board the ISS, and occasionally, very occasionally, when they've got some downtime, they will actually come on the radio, and they'll have thousands and thousands of people calling them, desperate to get an astronaut in their logbook, in their records. So it's very good. I've never spoken to one personally, but I know someone who has, and you know, they just exchange messages. They ask questions about what it's like in space, and they'll ask questions. The astronauts will ask questions about what the weather's like down here. So you know, it's just another thing that they can use, and it does happen occasionally. And then with the space theme as well, we have various satellites up there, and we actually have satellites that are dedicated for amateur radio use that were launched by an organization called AMSAT. Which again, we can bounce our signal off. So they're basically flying repeaters in the sky. So you can point your antennas up to them and you can send your signal up, and they will retransmit it back down. So again, giving you a really long footprint for communications. So where I was saying that, you know, a handheld radio is typically line of sight, you can access some of these satellites with a handheld radio without any extra antennas. And I know a guy up in Scotland who recently worked the east coast of America using a 25-pound handheld radio. He had a radio-to-radio contact with a chap on the east coast of America. So using a satellite that was halfway between the two. So, you know, it's doable. And again, we have all sorts of things on these satellites. You can send voice, you can send Morse over them, you can send data over them, and we can generally use them, abuse them to our kind of nefarious purposes, I guess. So yeah, they're quite good fun. And again, just another facet to the hobby. One more thing here, radio direction findings. This is another thing that we can do. Now, this is actually a whole sport within itself. As you can see from these guys, they take it very seriously. They'll hide transmitters in various parks or woodlands, and these teams will go hunting for those transmitters using nothing but an antenna and a receiver. They'll triangulate the signals and find them. It's a bit like orienteering, where when you find one, you punch your card with the stamp, and you know, first person back to the finish line with all the stamps wins. So again, just another facet to the hobby. Lots of things out there to do with radio that you can all do once you've got a license. So how do you get your license? That's the thing. Well, we have a body in the UK called Ofcom, the Office of Communications. I'm sure everyone's familiar with that. You probably heard it on TV lots. They tend to come up when there's been a data breach or when there's been some fiasco with telecoms. But the examinations themselves are organised by the Radio Society of Great Britain, which is, again, it's a voluntary organisation that people can choose to join. And they administer and run the examinations. And these days, it's all done online. They used to do paper examinations, but not at the moment. It's all done online now. So you book an examination, you download the software, you sit your examination, and it's I think it's still 25 questions, isn't it, John, or is it more? I'm looking for him to know. Yeah, still 25. You pass, it's multiple choice, and then you get your call sign and you're on the air. Simple as that. Nice and easy. And you'll learn, as part of that process, you'll learn all about radio and electronics, how to operate, how to communicate, different various licensing regulations we comply to, and a bit of safety in there as well. It's an interesting learning exercise to do if you're interested in radio and electronics, regardless of whether you actually decide to go for a license or not. Doing the course is actually a very interesting learning exercise. Really gives you a good foundation in kind of electronics in general. And then once you've decided you're going to go for it, you can do different classes of license as well. I don't really like the word class, but you can do different levels. I think that's a better one. So your entry level, if you like, is foundation. So that gives you a basic understanding of how radio works, a basic understanding of electronics, enough to know how not to kill yourself or anyone else around you, and how to abide by the law. And that will let you loose on all of the frequencies that we have available to us. Well, most of them. There's just a couple that you're not allowed on, but the majority of them that will let you loose on. And it will allow you to use 10 watts of output power as well, which might not sound like a lot, but you can quite easily talk around the world using that kind of power when needed. The next level up is the intermediate level, which basically lets you use a bit more power and gives you a bit more of a thorough understanding of electronics. And then the top level that we have in the UK here is called the advanced, and or you'll often hear it referred to as the full. And that focuses a lot more on radio theory. It goes into a lot more advanced electronics, a bit more about antenna theory, that kind of thing. And you'll come out of that with what we call a full or an advanced UK license, which will allow you to use up to 400 watts and pretty much any band frequency we have available to us. Interestingly enough as well, that full license, that advanced license class, if you've got that, you can also operate in quite a lot of countries abroad as well. So when you go on holiday, you can upset the wife or the girlfriend by taking a radio with you and sitting on the beach for half a day, calling CQ into nothingness. So it's quite the full license is quite a highly regarded license across the world, really. So that's your 3 steps. Each one of those is an exam. The exams get harder as you move up with more questions in. But really, the foundation license, I would say, if anyone is really interested in electronics and a little bit interested in radio, have a crack at the foundation, have a go. Once you've passed, it's yours for life. You do not have to resit. It doesn't cost you a penny to actually have. You just pay for the exam, and that's it. It's yours forever. And you can have letters after your name like me. Excellent. So there you go. UK courses and examinations are administered by volunteers. It's all voluntary. No one's paid to do this. No one's paid to do the licensing. And once you're licensed, you can claim a funky call sign. There's various different call signs that we issue in the UK, M6 and M7 being a foundation license level, 2E0 or 2E1 being an intermediate license level, and M0 or M5 being the current full or advanced license levels. Now, these call signs changed a bit in the past. You had G0s and G1s and G7s. But the current kind of licensing structure is M6 or 7 for foundations, 2E0s for intermediates, and M0s for fulls. So that's how you differentiate between how clever someone is, I guess. I mean, how dedicated someone is to the hobby. Yes, it's just a way of doing it. Sorry? How old they are. Yeah, if they've got a G, then they're very old and probably know Morse code. Yeah. So what do you need to get on the air? Like I say earlier, a little handheld radio, you know, can cost us, this is saying they cost as little as 50, but actually you can buy, you know, little cheap handheld radios for kind of 25, 30 pound kind of area now. Or you can spend as much as you want, really. I mean, there's a new radio that's just come out, which is about £5.5 grand. So you can go even more expensive than that. You can go up into the kind of 40, 50k for a radio that sits on your desk and looks very pretty. But you can start off extremely cheaply with a little handheld, and you can take advantage of the infrastructure that other amateurs have already put in place to help you get the most out of that handheld radio. You can also do things like going mobile. So I touched on a little mobile set earlier that you can put in a car. So here's a guy with a big 4-wheel drive who's got a HF radio in there because it's got a big antenna hanging off the back. And there's a guy with a bike on the right hand side there. I'm not sure he drives with that but I'm not sure he goes down the motorway like that. But he's obviously pitched up somewhere and is operating what we call portable, where he's just thrown that system together and he's making some contacts, getting it on the air, etc. Here's an example of a sort of a base station, if you like, from someone's home. So a couple of big radios there. There'll be big HF radios covering the shortwave bands. It's got a little VHF set there as well. And that's saying your typical kind of home station, your base station will be, you know, typically a HF radio, a power supply, something to tune the antenna up, maybe an amplifier if you want to run a bit of high power, maybe a PC or a laptop if you're running digital modes and things as well. And there's a couple of people there from Italy enjoying using the radio. Then we go on to various antennas. There's all sorts of weird and wonderful antennas you can put up, ranging from the small and discreet all the way up to the neighbors are definitely going to complain category. So you've got some wire antennas there on the left hand side, just basic bits of wire that are thrown in the sky and tuned to a specific length, cut to a specific length for the frequencies you're interested on. And then you've got some big Yagi style antennas, which are kind of a bit like TV antennas. They're very directional. They send the signal in the direction they're pointing in and they pick it up from that way. And that's just a good way of getting your signal to where you want it to go as efficiently as possible. And again, a very deep, again, it's another facet of the hobby that you can really dive into, and there are some crazy antenna designs out there, and there's no hard and fast rules. You can build your own and experiment to your heart's content. You know, you can get absolutely lost in them. Portable satellite operation, there we go, 2E0 HTS, one of the an intermediate license holder, and you can see there he's got a couple of handheld radios attached to that antenna, and he's talking through various satellites using a couple of cheap handheld radios and antenna. So he'll be working through one of the FM voice satellites there. Just decided obviously to go for a stroll in the countryside and set that up. Bounces signal through a satellite. Here's another satellite station, so Earth station satellite array. So this is obviously mounted on someone's house. Various bits of kit there. Just more examples of antennas, really. More examples of antennas. So we've got a vertical antenna there on the left that you typically use at your home, a base station style antenna. Give you access to a whole bunch of different frequencies very efficiently without upsetting the neighbors too much. And then on the top there, you've got a little VHF antenna that you would stick on top of your car. It's got a magnetic base on it, just to give you a bit more range from your handheld radio, or if you have a radio in the car, a way of getting the signal outside. And then the last thing I think we've got is resources. So if you're interested in amateur radio, you can have a look up the RSGB, the Radio Society of Great Britain. They've got some good resources online. Here's an example of the 3 books, the 3 manuals, if you like, for learning: the foundation, the intermediate, and the advanced. A few old pictures, they don't look like that anymore. They've recently changed. But the Radio Society of Great Britain is a good place to start. And I think that's it for resources. The other good thing to do is look up local amateur radio clubs as well. So if you're interested, have a look on Google for local amateur radio clubs, and you might find a club local to you, which is also always a wealth of information and knowledge there. Highly advise kind of contacting a local club as well if you're interested. So there we go, all good stuff. I hope that gives you a brief overview of it. I hope I didn't delve too deeply into it. And yeah, if anyone's interested, you can contact myself. Matt has my contact details, which I'm sure he'll share, or look up the RSGB, one of those 2.
Well, thank you very much.
Let me stop sharing my screen for you. There we go.
Well, thank you very much.
Let me stop sharing my screen for you. There we go.
That was incredible, fascinating. I didn't realise the depth of the hobby, and the uniqueness as well, with the ability to play around with these otherwise very carefully controlled areas of spectrum. That must be a lot of fun being able to go into those playgrounds.
Oh yeah, and I think, you know, I only touched on some of the topics there. I mean, there are hundreds, if not thousands, different kind of facets of the hobby that you can really get involved in. You know, and a lot of it is they're like endless rabbit warrens that you can run down. And interestingly enough, there's still a lot of things that are yet to be kind of disclosed and discovered. So you can really kind of get involved and innovate, and, you know, come up with new things in the hobby as well. And like you say, we're very lucky to have access to, I mean, we license holders are the only people in pretty much in the world that can just jump on these huge kind of sections of radio frequency and generally do what they like on there. You know, you certainly can't just build your own equipment and broadcast something, but with a radio license, with an amateur radio license, you can. Although the word that I've got to be careful with there is broadcast, because that's the one thing we're not allowed to do. We're not allowed to broadcast our messages, our data that we send. It must have an end recipient. It mustn't be just a general broadcast. And the only exception to that is, as touched earlier, a CQ call, because how do you talk to somebody if you don't know they're there? So the only time we're allowed to actually send a message that isn't destined for a specific person or a specific piece of infrastructure equipment is if we're calling CQ to say, hey, can somebody come and talk to me?
How did that work for things like slow scan TV?
Well, you send a picture for slow scan TV.
But who was the recipient? Often enough, like people just sort of broadcast interesting images.
Yeah, so for slow scan TV, you would send an image,
yeah,
and in the bottom corner, you would put CQ on it.
Ah, okay.
And then that is classed as a CQ call.
Okay.
Because what you're doing is you're inviting contact. So CQ basically means I'm here.
Yeah.
This is where I'm operating. Come and talk to me. And you can send as many pictures as you like, as long as they've got CQ on the bottom of them. So, you know, there's these little technicalities in the hobby. But the main reason that rule exists is to basically stop me going out and buying a 400-watt FM broadcast transmitter and setting up my own radio station on the amateur frequencies to oppose kind of commercial radio, because commercial radio pay a lot of money for their licenses and they'd moan that I'm stealing listeners. So it's all to do with the politics and the licensing infrastructure, if you like. So that's why that rule is there. The only time we're allowed to technically broadcast is when we're soliciting contacts. After that, you have to be addressing your communication to a specific person. And technically, even if you're in a group, so say there is 5 or 6 of you using a repeater, technically you are still addressing your communication to one of the individuals in that group, even though you're talking to everyone. So there's lots of little technical kind of bits like that. But in general, nobody really cares that much as long as you're not, you know, broadcasting the latest top 10 tracks over the airwaves. So
I thought there's no music anyway.
no music.
Nowadays.
No, you're allowed to play some music, but again, it's technicalities. So anything that is licensed and has royalties attached to it, you're not allowed to play. And you're only allowed to play, I think the definition in the license is within, again, the licensing wording in the license is quite open and free. And if you talk to Ofcom, who are the enforcing body, and if you say to Ofcom, okay, the license says that I can do this, but I can't do this. What specifically part of that can't I do? The wording that you'll get back from Ofcom, and I've had this quite a few times from Ofcom, is we are here to enforce the license, not to inform you of the license's restrictions.
Right.
So they will decide if you cross a boundary, and they will prosecute you, but they won't tell you what those boundaries are. That's up to you as an operator, as a licensed individual, to decide what is sensible and what isn't. So if you're doing something that you think actually it's probably not that clever, you probably don't want to be doing it. But in large, we are mostly self-policing. And to be honest, Ofcom have got better things to do than chase around with us, you know, when they're selling huge amounts of spectrum to 5G companies for hundreds of millions of quid. You know, they've got more important matters than oh, did Matt play 5 seconds too long of a top 10 hit because the radio was on in the background? You know, they don't really care about that stuff. So it's quite a relaxed kind of licensing structure.
It feels like these radio networks are an older and less used kind of communications network, like the internet.
Yeah. And
obviously the internet's exploded in a way that perhaps was quite difficult to predict in the early days.
Absolutely.
Is that the case with these other alternate communities? Are there use cases that would be surprising to us that might come to pass in 5 or 10 years?
Yeah, I mean, we still do things like we still do bulletin boards via radio. So I can effectively leave an email for someone on a bit of infrastructure somewhere else, so it never touches the internet. So we do things that are, I would guess, you know, 30, 40 years ago, you would never be able to just, you know, send a message to someone in Queensland, for example, you know, but you could have picked up the microphone and talked to them with pretty good reliability. You know, 5 out of 6 times you'd make contact with them and, you know, have a chat with them without costing you anything. That's the thing, you know, without using any other infrastructure, without paying for long distance phone lines and things. But yeah, the advent of the internet has kind of stopped that, because now you just send an email or you fire it up on Skype and away you go. But there are still lots of use cases for using amateur radio, and a lot of that is around experimentation. A lot of it is just for the sheer fun of it. You know, I know that I can pick up a radio and I can talk to someone, and it doesn't matter if there's, you know, a mobile phone outage, or it doesn't matter if I can't afford to pay the phone bill that month, because I don't, you know, there's no other infrastructure there. I'm not relying on any other bits of kit to do that. And then we've got, you know, we've got things that you just can't do over the internet, you know, like bouncing signals off the space station. You know, you're never going to do that. I've got time for a break on my screen. It's telling me to stretch.
Oh yes, there's an app on the laptop that Matt's using that reminds healthy computing.
Yeah, and I think you know, with the advent of internet and social networks and things, it's all very much now, and, you know, it's all instant and all the rest of it. Whereas amateur radio is a bit more of a relaxed and kind of slowed down pace. And then, again, in this day and age where everything is so instant and on demand, you know, actually it's quite nice to send a message to a bulletin board somewhere and wait 3 days for someone to pick it up and get back to you. You know, so yeah, it's an interesting thing. I'm just looking at the chat there, and there's we've got M0LMK EHW in as well. The licensed amateur there, fantastic, excellent, very good. Yeah, and what's the best way to overcome being mic shy? Oh, right, okay, that's a good question. as much as it's difficult, the best way is just pick up a microphone and use it. Nobody is going to laugh at you. Nobody's going to tell you off. And if anyone does decide to tell you off, then you can tell them where to go. The best thing to do is just pick up a microphone and use it. If you're not that confident in picking up a microphone and using it, then come to a local club and use the equipment at a local club under supervision if you want someone to give you a bit of a heads up as what to say and how to say it. Or if you don't want to go to a local club, go to one of the special event stations that clubs put on. We didn't really touch on special events, and special events are things like, so a good example, this weekend, just gone, we ran a special event station, the Hildestone Radio Society, G0HRS. We ran a special event station at the Northforeland Lighthouse, where we put some very big, silly antennas up in the farmer's field, and we set up a HF station and we talked all over the world using radio. We used a special call sign, GB0NFL for Northforeland Lighthouse, and it was a special weekend where lots of other nutters like us pitched up beside lighthouses and light vessels and put special call signs on the air to talk to other lighthouses. And we had great fun on Sunday when the thunder and the lightning rolled in and we had to take down a big antenna and it nearly zapped us. So that was good fun. I've never jumped back so quick in my life. So yeah, again, you can go to things like special event stations, which allow anyone, by their very definition of getting the license for that station, they have to allow members of the public to use the radio equipment. So if you don't have a license, you can go to a special event station, have a play with that. You can come to a radio club, and if they've got their own equipment there, you can have a go with that. Or you can team up with someone who is a licensed amateur. So if you want to have a go on a microphone, if you're not licensed and want to have a go, you can contact me and that can be arranged. If you are licensed and you just want an overseeing hand maybe, then again, you can contact me and we can arrange something as well. There's a huge network of licensed amateurs all throughout Kent. We're all very friendly chaps and lasses as well. And we can, very happy to help people get on the air and help them improve their operating or help them gain confidence, or even just give a taster of the hobby. So, so the best way to overcome mic shy is just get involved and just get on with it, basically.
Or use FT8.
Cool, great question.
Excellent. Is that it?
I say I remember that feeling.
Yeah.
Like the adrenaline builds, and you're about to say something, and you just say the shortest thing you possibly can, and then you'll just recover, and then you'll do it again, and then it's fine.
That's it. Yeah. After your first couple of contacts, it's just natural, And what you've got to remember is everyone makes mistakes. Everyone will say the wrong thing, or they'll slip up and not do something in the right order.
Yeah.
And nobody really minds. Nobody really cares. Nobody's going to tell you off for getting it back to front. I mean, you might get told off for getting it back to front constantly, but nobody's going to tell you off for getting it back to front. And we're all just people enjoying the hobby, really. And that's what it is. It's a hobby for fun. So as long as everyone remembers that, then it's all quite good fun. So.
It sounds like you don't suffer from trolls or any of that sort of stuff.
We do occasionally get them. I mean, the local repeater, the analog repeater, GB3EK, is plagued by someone who likes to interfere with it. So they will often send a signal to it while you are trying to use it. So that prevents you from using it. It's kind of akin to standing next to you and shouting while you're trying to talk. So there are a couple of them in amateur radio, but you're going to get them pretty much everywhere. You don't really get it so much on the HF bands, on the high frequency stuff. You get a little bit, but not a lot. I mean, it's nowhere near the kind of ferocity and tenaciousness that you'd get online. Because again, these things, they are enforced. Ofcom has been a bit lax in enforcing things in recent years, but serious problems are enforced and dealt with. And breaches of your amateur radio license can result in up to 5 years in prison. So, in the worst cases, I don't think anyone has ever been given a custodial sentence for breaching their license, but the authorities do have the power to do that.
Laws are tightening up around that kind of behaviour on networks.
Rules are tightening up, and I think what we'll see is, rules are tightening up in that kind of area online and on social media, and I think we'll see those rules roll into amateur radio and the radio networks. Currently, Ofcom's stance on it is that they don't control or dictate the content of the messages we send. So I think that may change in coming years as more of the focus goes on to kind of online behavior and things. I think we'll see Ofcom rolling that out across the board, not just across other communication networks. A good example of that is something that's recently happened, which is the electromagnetic interference compliance rules that Ofcom have recently brought out. So as radio amateurs, we're generally left to our own devices. We can put up silly antennas and put silly power into them. And, you know, if the next door neighbour's cat is walking along the wall right next to it, tough. But recently, again, with I think a lot of this has come from the pressure on 5G campaigners and things, where, you know, campaigning against 5G masks and mind control chips and all that stuff. Ofcom has rolled out this kind of blanket of electromagnetic interference reporting. So as an amateur radio station now, I have to do a compliance check on my radiated signal. So I have to make sure that my antenna is a certain distance away from members of the public. I have to make sure the output is a certain cleanliness, if you like. It's quite an easy task to do, but it's not something we've had to do before. But the reason I'm bringing it up as an example is because Ofcom haven't just rolled it out to us. They've rolled it out to licensed radio holders, so people who hold business radio licenses, marine radio licenses, broadcast radio licenses, and it covers everything from mobile phones all the way down to us guys down the bottom here. So you know, when they do make those policy changes, they generally tend to make them as a blanket change to be fair to everyone. So I think, yeah, I think as they toast up on social media, we'll probably see that roll into our hobby as well. Which isn't a bad thing.
You said it was easy to do your own compliance checking, but are you needing additional equipment to do that?
No, not really.
So you can check with a handheld.
Yeah, you don't. It's all. The nice thing about it is it's all theoretical calculations.
Oh, okay, right.
So as long as you
taking actual measurements.
No, you don't actually need to go out with like a field strength meter and measure the amount of power coming off your antenna. You can calculate these things just as long as the theory and the maths add up. Ofcom are quite happy. And what we actually do is there's a really handy online calculator that the RSGB provide. So you load that up in Excel, you put in the amount of power you're transmitting out of your radio, you put in your antenna parameters, and it tells you how far away people have to be from that antenna. And what you do is you ignore all that, you hit the save button, and you store it in a file on your desktop, and that's your compliance complete. You don't have to show that compliance to anyone. You don't have to upload it to Ofcom. You just have to physically do it. And then if an Ofcom engineer ever by chance knocks on your door because they're bored one Saturday afternoon, it's there to show them, and that's it. That's all you have to do. So
I suppose you can then demonstrate that people shouldn't be easily passing within a certain distance of the antenna.
Exactly.
It's on your roof and
exactly, yeah.
Well out of the way.
And again, there's mitigations as well. So my antenna, for example, at the back of my garden, I've got a HF antenna. There's a big pole at the back of my garden that goes up about 8 meters.
Yeah.
And then the wire goes up that pole and then comes back towards the house. Now, because I transmit with 400 watts sometimes, because I use a high power, people have to be, I think it's 4.5 meters away from that antenna in all directions. Now, the vertical wire, no problem. The horizontal wire, no problem at all. The vertical wire, because it's right up against my fence, if someone happened to be the other side of the fence, then they could be within that exposure zone.
Right.
So the mitigation is that there is a notice on the other side of my fence that says warning, high RF area.
Okay.
Job done. That's it. And then members of the public are informed that that is a high RF area, and that's all you need to do to be compliant. That's it. So, you know, if you're so behind me is a private car park, for example, but if behind your house or the neighbour, you know, you could tell your neighbour there's an antenna there and that there is RF around, and you could explain that it's non-ionizing radiation, so it's not going to do them any damage.
Yeah.
As long as they're aware of that fact and they're happy with that fact, you're compliant. Simple as that.
If they're unhappy,
try and move your antenna 4 meters closer. Yeah.
They decide they set a chair right up in that corner.
That's it.
You have to just try and figure out.
Exactly, you work around it. Yeah. Reduce your power down, change your antenna system for something else, a different type, anything like that. Okay.
So Meat Lotion was just saying a couple of things. Well, there's a few chat messages come up there, which I think you can see on your computer.
So I had my foundation license nearly 18 years. I had less than 5 conversations on the radio. Excellent. And John's come back with a good one. Use digital modes. Have a go with the digital modes. FT8 is a very good digital mode. You don't actually have to say anything with FT8. It's all done on the keyboard, and you don't actually have to type anything either. It's all preset messages. So the aim of FT8, it's one of those communication, those digital modes I was talking about, where you can actually decode the signal when the signal's not there. It's under the noise. And because of that, it sends preset sentences. So I would say CQ M0LMK, and I would send my grid locator, which is my location. Yep. So for my house, it's Juliet Oscar 01. That's just the grid reference where I live. Someone will come back to me and they'll say M0LMK, 2E0DUE, Juliet Oscar Romeo 1. They'll give me another grid load. Then I will send them a signal report. So I will say, you're minus 23. They'll send me a signal report, and then I'll send them 7.3, which in shorthand means thank you very much, goodbye. And they'll send me 7.3, and that contact's completed. I've exchanged a piece of data accurately and reliably with somebody else using no infrastructure apart from the kit that's on our desks. So FT8 is a good mode to kind of use that license and have fun with it and see how far you can talk on your 10 watts foundation. And then you've got other things like PSK31 is another data mode, and that's more of a chat mode, so you can type messages on the keyboard and send that. So there's lots of different data modes you can use where you don't actually have to use a microphone to engage in the hobby and enjoy it. So that's a good call there, John. I missed that. And then I used to use 11 meters regularly back in the 90s. Is this still popular? So 11 meters is still in use. It's gained a recent boost because it used to be limited to FM, frequency modulation, the mode that you're transmitting. And it was limited to 4 watts of power, so not a lot of power. But recently, a few years ago, Ofcom changed the rules, and they allowed something called single sideband mode on those frequencies, which enables much further communication distances. It's still voice, but you can send the signal much further due to the way it's transmitted, and they increase the power to 12 watts when you're using that mode. So it's gaining a bit more popularity. 11 meters is still in use. Still lots of CBs out there, not so much on the FM bands, more on the SSB frequencies. And then you've also got, we've got an amateur band just underneath 11 meters called 10 meters, which pretty much has the same characteristics as the CB band as well. But it's still there and still in use. There we go. Anything else? I think that's covered everything in the chat, isn't it?
Now, you've brought some actual hardware along over there. While you were talking, Dan, this is Dan, this is Matt is Dan, and there's some regulars in Zoom land over there as well. But Dan's brought some kit as well.
Excellent, fantastic.
Should we have a bit of a kit?
Well, part of it was I haven't used this kit for 10 years, and it was a chance, I think, to. I'm an M0, but I feel I've forgotten an awful lot, and I really could deal with firing this up with some other people in the room to see if it still works and so on. So I brought a little handy, which I think hasn't been charged for 5 years and still has 6 watts on it.
Still has some power. Yeah, excellent.
Yeah. So no, it's gone down there. Okay. But it's for it's not got enough. But it's on GB3 UK.
Okay, excellent. A little Yaesu radio?
Yeah.
I've got the camera.
Oh, okay. But you'll see it starts up and then
stick it in the charger. Yeah. But, again, another good thing, if that was a mobile phone that had been sitting in your cupboard for 10 years, it would be obsolete now. You wouldn't be able to use it on any networks. It'd be dead. But the radio, just tuck it out, turn it on, and away it goes.
I'm sure I've shown you this before, years and years ago. So this was what I used when I travelled around America.
Excellent.
Can everyone hear Dan speaking? John, can you give us a thumb up? Yeah, I can.
Okay, well, we should probably put out all the spiders and everything before we show everyone on the camera. But yeah, I might just try and figure out how to put it all together.
A radio in there.
Yeah,
Icon.
it's an icon. Yeah, icon mobile. So
Excellent.
just going on the phone. But yeah, should we show the actual stuff we know works first? And then I can try.
And again, it's just it's another example of another facet of the hobby. You've made this kit to go on your bike, and you're using it while you're travelling around and staying in contact with people.
Oh yeah.
And
but it's the reason I had to quickly get my advanced license because I was heading abroad and then suddenly realised my foundation wasn't going to cover me. Yeah. So
this is like an early version of Airbnb.
Looks like, I don't know, cash in the attic or something. What else have I got in here? Can't read that. What else?
So there's again another part of the hobby is that you get these people that they're very keen on portable operating.
Yeah.
So they will build kits that have a radio and a battery, and some of them even have like little tablets connected to them. And they will take these things into parks or beaches or mountaintops and just operate from there. Because I mean, the best place to operate radio is actually out in the ocean, where you're away from sources of electromagnetic noise. So you're away from computers and solar panels and plasma TVs and things. So you get these enthusiasts that are in parks and all sorts. And this is another example of it. You built a whole kit into that case, and away it goes.
So it used to be that this went in here. And then a Velcro to hold it down. It'd be amazing to still work.
All the control cables.
Yeah, racks. And some of the.
I like the way that you put the foil on the inside of the lid there to act as a ground plane for the antenna.
Yeah.
It's excellent.
So this is what John G3YCB did for me years and years ago. And then it was just gluing the foil on, and then and then sitting I think over towards Joss Bay or outside Captain Digby area. We'll plug into the car battery just to make it all work. But yeah, we should show the
power out a bit.
If that's all right. I'd like to do that.
Over on the other table is kind of a melding of RF of normal radio, digital radio, and the internet as well. So we've got a handheld radio there in the middle, which Matt is showing us. There we go. So that's a handheld radio. So that does traditional analog radio, so FM, you kind of standard water stuff. And it also does a mode called DMR, which is a commercial digital data mode. And it sends digital voice, and you can send text messages and things across it as well. Sitting next to it is what we call an MMDVM hotspot. So it's a hotspot. So that has a little Raspberry Pi on the base, and then it has a small RF chip in it, which effectively produces a mini radio signal, and it connects off to one of the outer networks on the internet. And what we've got that doing right now is it's connected to a network called Brandmeister. And on that network, there are various, think of them as conference rooms that you can kind of dial into. So they're kind of conference call rooms. So this one is connected up to what we call Talk Group 9, which is worldwide. So inside that room, there are lots of other people that have these little devices sitting on their desks at home or in their car. Or there are repeaters that are connected up to that room as well. And there are people using these little handheld radios. So you're using your amateur radio license to talk from the little handheld radio there to the mini hotspot. And then that is taking your voice and squirting it out over the network, over the internet, and connecting it up. And it's coming out of every other radio all over the world, is also connected up to that conference room, if you like. So it's just another demonstration of how you can use a relatively cheap, small handheld radio to actually talk to people all over the world. And digital systems are quite nice because they have lots and lots of different groups that you can get involved in. So you'll find if you're interested in pond keeping, there will be a talk group or a conference room somewhere on the digital network where everyone who's got ponds in their garden likes to keep koi will hang out and chat.
So it's it's like I say, it's a bit like Facebook without Facebook. There's all these different interest groups out there that you can kind of get involved and enjoy. If there's something you're interested in, there will be someone else out there that's interested in it as well. And, yeah, very good to maintain and talk.
This camera stopped working.
I have 4 Pis. How can I build one myself? Do you have links for information? So you need to look up the software. It's open source software, and it's called PiStar. So Pi and then a hyphen and star. PiStar. So that's the software that you run on these little hotspots, and you will need one of the Raspberry Pi hacks to sit on top of this. But if you look up PiStar, you'll find lots of information about the software and actual Raspberry Pi hacks. And the actual modem, if you like, it's called MMDVM. So Mike, Delta, Victor, Mike, and that's the kind of the modem and the software that's behind this. So there you go, various different hacks that you can buy and stick on top of your Raspberry Pi and turn it into a hotspot. You still need to be a licensed amateur to use it, which isn't a problem for you there. But you still need to be a licensed amateur because the connection between the hotspot and your handheld radio and the RF is using your license. And I typically use this. So for example, we have the big repeater on top of the Victor house that covers pretty much the whole of Thanet and beyond. But when I'm using that repeater, everyone else who wants to use that repeater can hear me. So I end up tying up that resource. Or in some cases, for example, I live right on the cliff top above the beach. Sometimes I'll go for a walk on the beach and I'll take a radio with me. And I won't be able to access the repeater because I'm in the shadow of the cliff. So the radio won't go over the cliff. It kind of travels in straight lines. So I will use the little hotspot at my home, and I'll be able to talk back to that while walking along the beach and use that instead. So there's several use cases. I've got a smaller radio up there, which you might have seen when Matt was moving obviously get the camera up again for me, I think. There's a smaller radio up there, which is the little kind of pocket radio. The range on it isn't particularly great, but again, perfect for when I'm walking around the house or up in the workshop. I can have that radio in my pocket and I can be listening to a conversation about, I don't know, getting the best from your mini lathe machine. A couple of guys in the US might be talking about that, or I might be listening to a conversation about, a massive lightning storm that's moving across the German border, which happened on Saturday night. So I was listening to a couple of German amateurs talk about that. So there you go, little tiny radio that you slip in your pocket and away you go. Not much use if you want to talk for miles and miles, but perfect if you want to talk back to your little hotspot and still enjoy the hobby while wandering around the home. There we go. I hope that gives enough information on the hotspot for you.
So on this web page, I saw the cheapest one on Amazon anyway. It's the antenna hotspot module for about 30 quid.
Yeah, that's that right. So one of those and a radio that can decode DMR. So DMR is the mode. Well, again, these hotspots you don't actually need. I use DMR just because that's the radio I have. But there are lots of other digital voice modes. There's a mode called D-Star. So if you've got an ICOM radio that's fairly recent, it will probably support D-Star mode. There's a mode called Yaesu Fusion. There's a mode called P25. We don't really use that much over here in the UK, but it's a mode. And these hotspots support all those modes. So they'll talk to various different digital modes. They'll still talk on the same networks, and you can link the networks together. But you need a digital radio that can handle one of the modes the hotspot supports and the hotspot, and away you go. And you can pick up a cheapish DMR capable radio, about 45, 50 pounds. A hotspot, another 50 quid, including the bits. So for around the kind of £100 mark, you can be talking to other stations all over the world. Or even, I spend probably 95% of my time just listening on the digital stuff, because there are some very interesting conversations that happen, I'll have it on in the background while I'm doing something else, and just have it ticking away. A bit more interesting than having the news on. So, yeah.
Well, it sounds like an incredibly accessible hobby with very few boundaries and many different directions that you could go within a large, global community. Your fantastic description makes me think, what's not to love about it? Really.
Yeah, and I guess another thing to point out is you don't actually need your own equipment either. So once you've got a license, you can use club equipment. You can use stations that have been set up for special events. So you don't need to go and spend lots of money on buying things. And if you progress through and you do your full license or your advanced license, then you are allowed to then remotely operate stations as well. So one of the reasons that I hold a US call sign is I went and sat the American exams, and I hold something called a general license in America. In America, again, they have 3 license levels. They have the technician, which is equivalent to our foundation. They have the general, which is equivalent to our intermediate. And then they have the extra, which is equivalent to our advanced license. So I went and sat, and I didn't really study that much. I should have really studied. I passed the technician and the general. I failed the extra by about 3 questions. I had two goes at it, and I failed by 3 questions each time. So I stuck with the general. I'll probably go and do the extra next year when things are more accessible. But what it means holding that American license is it means that I can access stations that are in America for free from my own living room, and I can use those stations via internet connection. So I'm connected to the US via the internet, but then I'm broadcasting, I'm transmitting from the US. And they have some very, very impressive stations out there that you can just use. And these are radio amateurs that have built this kit, invested in this kit, used this kit, and then gone, do you know what would be really cool? What would be really cool would be to let other people use my kit. And there's no charges, no fees.
Imagine if someone had done something like that on the internet, how much abuse and and wreckage would be created from that opportunity. So completely different.
Yes, completely different zone. I use US stations quite a lot, and the reason I use them mostly is because you're not allowed to do it in the UK. So with a UK license, you are allowed to operate your own station remotely. So if I went to France for a week, I could remote into my own station at home and use it. I could use a club station remotely, as long as I'm using my own call sign on it, or the club's call sign. But I'm not allowed to use your station or your station. So in America, you can use other people's stations. They have a lot more space in America, so typically their houses have more land around them, which means they can put out bigger and more impressive and more efficient antenna systems. And they're allowed to use 1,500 watts of power, which is 1.5 kilowatts of power. So I can remote to an American station. I can use my American call sign. I can use 1.5 kilowatts of pure RF energy through big antenna systems, all from sitting in my own comfortable chair, and I can do it all from my phone. So everything is done on your phone or a tablet. So there's no need to invest in expensive equipment, and you can use these stations that are, they're some of them hundreds of thousands of dollars have been invested in these things. I mean, you're talking 400-foot high towers with massive antennas on. So again, it's another facet of the hobby that's an interesting facet to go down. So very good. And the other reason I hold a US license is because with a UK license, with a full UK license, you can operate in quite a lot of other countries. There are agreements that are set up where you apply for a reciprocal license. But some of those countries, there are some countries where that's not the case. So, for example, I go to Mexico fairly often, and in Mexico, they don't have an agreement with the UK, but with a American license, I can get off the plane at Mexico and I can operate because they have an agreement with the US. So I operate using my US license rather than my UK license. So it gives you a bit more variation around the world as well. So very good if you like traveling and you like using the radio. So and there's no limit to the number of licenses you can hold. You can hold a US one, you can hold a Canadian one, you can hold an Australian one if you want, and they all have their different benefits and drawbacks.
Yeah, there's a few things on, a couple of messages on in the chat.
Okay, yeah. Is the Anytone 878 a good DMR radio to get? Yes, I would say it's probably the best DMR handset you can currently buy. That's the handset that's up there. That's an 878, very, very good, very easy to drive, very good memory capacity on it, and nice clean RF performance as well. So it's not, you can buy a lot of cheap radios, might not have the cleanest signal out there, and usable for amateur radio, but they might not be the cleanest. But the Anytone is a very good, clean radio for the money. Well worth it in my opinion. So that one's very good. And yeah, you found one on M0LMK, Martin Lynch. I'd suggest Moonraker is a good store to look at as well. You'll often find it slightly cheaper on Moonraker. So have a look at them. And the chap who runs that is it's run by a single guy, and his customer service in my opinion is absolutely superb. So have a look at some of the smaller suppliers as well, would be my suggestion before you start handing over money.
Is this the right site here?
That's Moonraker, yeah. Yeah.
I'll send all of the links that I'm putting in this browser you can see in my window. I'll send that out afterwards, after this meetup.
Excellent. And the Anytone radio is a DMR and an FM radio, so it will be both. And it's quite wideband as well, so you can program it for other frequencies and various things. And it works on VHF and UHF, so you'll have no problem accessing all the local repeaters, all over the world on VHF and UHF. You'll have no problem. So and there's a plus version. So the plus version, if I remember correctly, the plus version gives you built-in Bluetooth, and it gives you built-in GPS. And one of the benefits of that built-in Bluetooth means that it will work with a Bluetooth headset if you want to look like you're calling from the 1980s. But it will also work with a Bluetooth PTT button. So, for example, I don't have a radio in my car. I drive 3 different cars on different occasions, depending on what I'm doing, because we share them within the family. So I don't have a radio in each one. What I do is I put my handheld radio in there on a dashboard mount, and then I attach the Bluetooth PTT button, the push-to-talk button, I attach to the gear stick, and then when I want to talk, I just push that button, and the radio goes into transmit, and I just talk. The microphone in the radio picks it up. So you're hands-free in the vehicle, and it means I take one radio around with me everywhere, and it does everything I need to do. So if you're interested in taking it mobile or being able to put it on your desk and not having to hold it, then the plus version is a good one to go for, because it gives you the Bluetooth buttons and capability as well. That's all right, no problem. You're welcome.
Are there any?
Yes, it does normal FM as well. So it will work on all the analog repeaters as well. And I've just looked over to mine, and it's just sent APRS. That's another thing it does. It sends positional data if you have it turned on. So I think mine just sent some APRS. It might not have gone through the network properly because it's not connected to an APRS box at the moment. But there is a website called aprs.fi, aprs.fi, and that is a kind of an open source mapping application for worldwide, where all the positional data from these radios is displayed, so you can look up where your mate is and which way they're going, etc. And go and nick all his radio gear that's broken home.
APRS.fi. I forgot to swap over the feed, so when I was showing it on the camera, it wasn't going anywhere.
Yeah, APRS.fi. And yeah, this is again an entirely free service. There's a whole bunch of digipeaters, which are effectively repeaters for data, for positional data. And you can see, if you zoom in on the map somewhere in Kent there, you'll find mobile stations that are driving, showing you where their position is, how fast they're going, etc., etc. People are walking. You'll find weather stations on there, which are remote weather stations, which are sending out data via the amateur network. So again, they can be remotely sited. They just need a solar panel and a small battery, and they can spit their weather information out every 15 minutes, and it will come to this website and update. So yeah, quite a useful, another useful resource to dive into and play with.
My internet's going very slowly. How much bandwidth does your hotspot take?
Hardly any. Hardly any. Typically a couple of kilobits a second.
Wow.
It's just compressed voice. That's all it is.
Right, here
This
we are.
website is a fairly slow website anyway, especially when you're zoomed out, because there's a lot of data being loaded on the Maps API there.
So there's G0HRS, which is the repeater on top of the
That's our local radio club, yeah.
Hildeston. Yeah.
That's it.
and you're not showing up because you haven't.
I don't think that hotspot will pass the data through. So although my radio has just transmitted my position data, there's nothing to receive it, so it's not going to filter back to the internet. So if I had it connected to the local repeater, then it would connect back through and filter back. So you'd be able to see it pop up on the map here.
And the rate, the distance between the local repeater and here is an acceptable kind of.
Oh yeah, I mean the GB7TH will cover pretty much the whole of the Isle of Thanet, quite a lot of Canterbury, and it goes down to Whitstable and Herne Bay, and it goes down kind of Dover, Chesterfield area as well. And that's just on a handheld. So if you're in a vehicle with a better antenna, that's further. And if you're at home with a big antenna, that's even further. So yeah, it's a good coverage repeater, and it's purely because we have a saying with VHF and UHF frequencies, and that saying is height is might. So the higher you are, the further the signal is going to travel, because it's a line of sight mode. You need to really be able to see where you're transmitting to actually get there. So that's why we put repeaters on big high buildings.
Right.
And then moan when the wind shoots gets out of fire.
Okay. Now, I think Dan's emptied the box.
Yes.
Onto my lovely tiny desk.
I'm very sorry about this mess.
So maybe we should
there's a lot of sort of perishing foam and things like that. So it's been a long time.
Go with all the electrics.
Yeah.
Okay. Thank you. Well.
Sorry to take over the chat. That's absolutely fine. And I'm sure Matt will share all my details with you if you want to.
Yeah. So just while Dan's unscrewing something, I'll go back to this page, and this is Matt's web page here. M0LMK.co.uk, and there's a shop with some. Well, would you like to talk through it?
Yeah, I mean, I sell. So my main job, which I didn't mention, was I run a small B&B, a small guest house in Broadstairs during the summer, and then when we're closed during the winter, I do a little bit of web development, and I do a bit of penetration testing as well, mostly focusing on the RF side of things, Wi-Fi networks. But as a sideline to that, I also run my own small shop online, and I sell various small products for the amateur radio community and the radio community in general, ranging from simple antennas and 3D printed things, really. My own website is kind of I think I say it's a musings of a deranged madman, I think. Evil genius. I put up on my own blog things that I'm working on, things that interest me, something I've done that I think other people would be interested in. I don't publish too much because I get quite a lot of questions and things about the stuff I do publish. So I try not to put too much up on there because it'll be overwhelmed with things. But I put the most interesting things up there. There you go. There's a shot of my shop with a few GPS units in and things that I build and ship out. And I ship those all over the world. I don't sell a huge amount through there, but I sell enough to make it worth doing every month and have running. Yeah, it's a good place to experiment, and again, just another facet of the hobby that if you get involved in it and you come up with something that you think people might like and enjoy, then there's opportunities to make a commercial interest in it as well. So, there's GB0NFL, which is the special event station we run. I don't think we updated this page this year. I think we came away from using my website for that and we used a different one, but yeah, it's all there.
And is this a good way to get in contact with you?
Absolutely, yeah. Click the contact button and get in contact with me via that. Or you can just send me a direct email, which is just Matt with 2 T's at M0LMK.co.uk.
Okay. I won't send an email from you to you.
Perfect.
I just put that type of
And you can find me on Twitter as well, which is just at M0LMK. The full sign is everything.
Trying to remember how to use it. It's been a while.
Okay.
But it's. Can you suggest a frequency?
What are you on? So 145,500 is the VHF calling frequency. So that's where people will be. But to see if it's actually working, I would go to 144,800.
Okay, I've got to figure out how to get. Alright, switch band.
And 144,800 is the APRS frequency, so you should hear data packets on that frequency coming and going.
Okay, so 144,800. 800 going out.
And you might hear some data coming and going on there. You just watch up a bit and then just
That's it. We're up.
give it a few minutes and see if it picks anything up.
144,800.
Yeah, it's a bit late in the day for APRS. A lot of people have gone to bed now, so
Yeah.
you might get something on there.
So what are we looking at whilst we're waiting? What's that, and what's it connected to?
Okay. So I've taken the base unit of this mobile radio out of the case just to try and remember what all the various cables did. It used to have a box I built which took GPS signal in and then generated packet radio out and then fed into the radio bar another signal point on the front. Yeah. I think that might have done that.
No, that wasn't me.
But this then used to send my position from the motorbike through the packet radio network, and then it got fed to my website, which used to then draw my position as I went around the country. This was 2006. It was a long time ago. So things have definitely got a lot easier since then. Yeah, and so I haven't really used this for about 10 years. So it's really nice to see that it still appears to be running. I mean, I haven't tried transmitting yet, so I don't know if we'll.
Well, we can give that a go if you like.
Yeah,
we can go for a different frequency. I've just put my radio into analog mode. So if you go to, if you do 145,450.
145. 450. Yeah.
450, and I'll just go and stand outside so we're not kind of crashing each other. And I shall call you and you can see if it works.
Brilliant. Here we are. Live test. Oh, hang on. I'm on. Right, I need to take this off. This is in an offset mode at the moment, so I have to figure out how I turn that off.
I heard.
Yeah, we have that. I know. I'll go on this one. Yeah, we did. I've got an offset mode still, so I switched the other band.
Okay, yeah. So an offset mode is where if you're using a repeater, it will listen on one frequency and it will retransmit on a different frequency. So your radio will want to listen on the frequency that the repeater is transmitting on, but you'll want to transmit on the frequency the repeater is listening on. So an offset mode allows your radio to do that, transmit and receive on different frequencies. You want a different band?
No, I've just done the other.
Okay,
side, so M0LMK listening. Still transmitting.
Loud and clear, no problem.
Excellent.
It worked.
There we go, lovely.
There. That's marvellous.
And you've probably got a bit of data traffic off my signal there as well.
I think the push to talk might have stayed down. I've probably got a weird. No,
I'm sending. So if I key mine, it's not doing it now, but I'm sending APRS every so often.
Okay.
So that noise that you've got that afterwards That's probably my APRS coming through.
Cool.
There you go. That's
Oh,
all,
very
that's all
pleased.
working and operational, isn't it? Excellent.
After 10 years.
Oh,
Yeah,
10
the
years.
geekery makes it live. Yeah.
Really
Thank
happy
you very
where
much,
you go.
Matt. Excellent.
So the important frequency is 145,500,
Yeah.
and that's the UK-wide calling frequency. So if you want to talk to someone, you come up on that,
Yeah.
you call CQ, and they'll pop back. But if you just set it up and have it listening on that frequency, you'll hear people coming up and calling people, and you'll hear them say, "Oh, should we move to 144,500, 145,550?"
Yeah.
And they'll change frequency. So what they're doing is they're calling on a single frequency and then moving somewhere else, so they're not tying up that frequency so others can't call each other.
That makes
So,
sense.
yeah, it's quite fun
You
to do.
described the offset mechanisms.
That's
Okay.
right.
Yeah. I've just got to figure out how
Have to put that on.
to control it now. Yeah, it's
Okay.
a duplex mode, isn't it? So
That's
that'll
it,
be it. Yeah. Let's figure out how to control that.
That's cool. So, well, I think we've reached the point of the evening where we give a hearty round of applause
Yeah.
to the speaker.
So thank you very much.
It's really,
Well done.
really good.
Thank you very much. Matt.
It's wonderful. Very, very good. Excellent. So maybe we'll return to what's going on in the background afterwards, but
Yeah.
I can feel that you're all itching to find out what the mystery object is. So we'll tick that box now. Let me just change this one to that one. Right. So this was the object, to remind you. Okay. Are you ready for the answer? Do you want some more time?
I know. Is it to do with compression?
Not really. No,
Oh, okay.
that's not what they're for.
Okay.
No.
Well,
Well, 2 or 3 people did get it right in that it is an anti-vibration mount.
okay.
And I thought after last week's Furby and my massive rabbit hole down to global warfare and back up to a Ramsgate museum, I thought I'd keep it straightforward. So that's it.
Keep
Really.
it light. Yeah.
Yeah.
Okay. Right.
But when I was a young engineer, my first job as an engineer, this chief engineer came in with this and said, "What is it?" And I didn't know, and it's bugged me ever since. So since then, I've been trying to find out what everything does, so I'm never in that situation again.
Very good.
And now no one here in this meetup will ever not know what that is. I was going to go down a bit of a rabbit hole into looking at other types of vibration, anti-vibration mounts and decouplers and that kind of thing.
Yeah.
Like steel wire loops, springs, you often see those under heating units outside offices, and anything with moving parts.
Yeah.
Where perhaps you don't want noise to get through, or just generally they're quite vibrating. You don't want that to shake your building or itself apart. But if you really want to know more about all of this wonderful stuff, you can obviously Google it yourself. I won't do the rabbit hole here.
Okay.
After saying I'm not doing a rabbit hole, I nearly went into a rabbit hole there, didn't I? Yeah, but it's so fascinating. Even with something as sort of simple as this, there's so much ingenuity in everything. Like people using blue tack to isolate speakers is anti-vibration mounting. But yeah, so there's lots of stuff there. But I'm going to move on. Oh yes, now I'm quite embarrassed by this, but I got stung by a banking fraud a couple of days ago, and I thought I was, a bit savvy about stuff, but I fell hook, line, and sinker for it actually. So I just wanted to confess that really, to remind myself and everyone else that it can get anyone at any time when you're not fully switched on, perhaps. And my experience was that I had a phone call about a month ago claiming that there was some kind of fraudulent activity, and that they were going to do something to do with my card. Nothing happened. I wasn't compromised at that point, but I guess they put a thought in the back of my head that I had been. So when I was phoned up again a month later, they deployed the actual scam, and my guard was a little bit down, perhaps because something harmless had happened. I was suspicious for both phone calls, and it was a voice call. And afterwards, I phoned the bank back afterwards straight away, and it was all fine. But yeah, it was surprisingly sophisticated in that human engineering kind of way.
Yeah.
Even though I was suspicious, maybe the pair of calls worked well together. So yeah, there's lots of advice online, and it's part of that rabbit hole that I went down last month as well, wasn't it, with that kind of stuff. But yeah, just another warning to myself and everyone else to always initiate the phone call at the very least. Never continue with something from a phone call that you get from the blue. Don't click on any links that you don't recognise in text messages or emails, and lots of other stuff that seems obvious, but it's incredibly easy to do when you're not, you've got
you're
half there.
I think.
So yeah, I am very embarrassed about that, but I thought I should say that it can get even people that think they.
I wouldn't be too embarrassed about it because I mean, in my experience working with the pen testing side of things, human kind of interaction is always the easiest way in. Always. You know,
we are the weakest link.
Absolutely, it's just human nature, you know.
Yeah.
Yeah, there's various tactics that I don't do any of the physical stuff, but there are various tactics that teams that do the physical stuff will employ to gain access to networks and things. And they can be one of the most successful ones I've ever heard them use is basically dropping a bunch of USB memory sticks around a car park with 2021 redundancies .xls on it, because everyone's going to pick it up and put it in and go, I'm going to check my name's not on there. And, bang, you're in, find someone that's got an admin access, and that's it. Job done. So it's always it's always the weakest link. So I wouldn't be too embarrassed about it. And these schemes are, some of them are really advanced and very clever. It's the first time I've heard of one where you're contacted beforehand and then contacted again. I mean, that's pretty crafty. That is. So yeah, very crafty. Keep your guard up.
Yeah.
Okay. Thank you. Yeah, I've got that off my chest a little bit.
Well done.
And then that's the end of this bit of the thing. So another round of applause for Matt wouldn't go amiss.
Thank you.
And for Dan bringing your stuff in as well. 10-year-old kit's still working.
Dan just making a mess.
Welcome back to the hobby, Dan.
Thank you very much. Cheers.
And the next bit is just the social part. So if anyone on the Zoom call would like to start a discussion or say something or say anything, now is a good time to do that.
I'll say good night then, Pat.
I should unplug my headphones in case someone does say something.
I'll say good night, everyone. Then. Good
Sorry,
night.
John. I wasn't listening then. Could you say that again, please?
Good night.
Good night, John.
Or 73s, as we say.
73. Yeah, excellent.
73. Yeah.
As long as there's no 88s from him, we're fine.
Fabulous.
I never really got into the whole kind of 73 and 88, and I never really got into all that because I use voice.
Yeah.
When you're using voice, it's just easy to say thank you and goodbye. It's just polite.
Yeah, everyone understands. So is it all English?
It's all English. You might find some amateurs having a conversation in their native tongue if they're talking to each other.
Right.
So quite often we're quite close to Europe. We hear quite a lot of Germans quite often. We hear quite a lot of Italians, mostly because they're allowed ridiculous amounts of power, so you can hear them wherever you go. And you'll often find them talking to each other in the native tongue.
Yeah.
But pretty much every licensed amateur understands the basics of hello, this is your signal report. I hope you are well. Thank you very much. So I mean, we're lazy. We're blessed because it's all in our language, so it's perfect. Yeah, most people can hold a conversation pretty well in English. So, and then you get smart guys like my friend Steve, who will spark up a conversation in German or French or Spanish just because he can. We talked to someone in Sweden the other day, and he was back to them with a bit of Swedish. Really? Just like that, yeah. Just like that. But he's an English teacher. Right. He likes languages quite a lot. So not in depth, but enough to have a nice conversation.
Yeah. Strengths and pleasures.
That's it, yeah. And it's amazing what you'll pick up as well. So you'll be speaking to someone, they'll talk to you in English, but you might say thank you to them in German or Spanish or French. So, you pick up a little bit of other languages if you need to, but yeah, we're very lucky that most of it's English. So.
Yeah. I'm going to try and build this into the box now and see. Excellent.
Put it in.
Yeah, and then see if it will still work. I need to.
I've got a few images, Matt, on that memory stick. Is that in here now?
I dumped the whole Geekery Talk folder on the desktop.
Okay. So I don't know if it's worth putting those up, but
I can do that on here, or you can do that on there too. You can do it just as easily on your. Sure. You have to be careful not to. They're long ones. They snap.
Oh, okay.
So,
I think I put one of these.
So this one is left half of it behind, so they're quite long. So pull them out that way.
Like that. Yeah. Okay.
Thank you. I'll unpin me, and then pin you.
Yeah. I've got a signed out thing on here, but I should be able to pull it up. There's I'll share this. Let's have a look. I thought I'd put some kind of images. I just threw them quickly from my Google Drive onto a memory stick. Just pull them up. Might be interesting for some people. This is a satellite antenna, so 3D printed with a little bit of pipe in the middle, and that lets me talk to various satellites that are overhead.
Wow!
3D printed man-made antenna. This one is also particularly very good at listening to Milsat, which is about 250 odd megahertz, and is currently populated by Brazilian pirates, which is quite good fun. Down in Brazil, they use it as their little kind of their own mini mobile network communication thing. They use US military satellites to bounce their signal off. Practically untraceable, very hard to find the origin of the signal because it's going up to the sat and coming back down. US military can't really do anything about it, so they just let them do it. And the satellites are old satellites that they don't really use anymore because they've moved over to everything digital. So it's cheaper for them just to keep them in orbit than it is to try and deal with them and get rid of them and stuff. So they just leave them up there and yeah, so just an example of something. What else have I got in there? A few other things. That's a 3D printed antenna coil. So you use I use a fishing rod on this, a 7 meter long fishing rod, and I can take that down the beach, stick it in the sand, and I can move that crocodile clip up and down those windings to find the matching point for the frequency that I'm on. So a nice little portable antenna. Just an example of stuff that you can 3D print. Next one, there it is. So there it is on a fishing pole with a wire going up to the top of the pole. So I can get on the radio from the beach, which is quite nice. This is the North Foreland event that we've just done with some silly antennas in the air. That's a 12 meter mast closest to us with two huge, great big Yagi style antennas. So that was using VHF, and they were talking into Germany and Belgium and the Netherlands with that, running 400 watts. Just behind it are a couple of 18 meter tall vertical antennas. You can just about see one of them, the black one to the left of the picture of that.
Yeah.
So they're quite large antennas. So that's the farmer's field we were in, North Foreland White House behind us. There's the two 18 meter vertical antennas. They're 18 meters tall each. Those two antennas are actually connected up to each other. They're called, we call it a phased array, where we feed both antennas with a radio signal, but we feed them slightly out of time. And what that does is it manipulates where that radio energy is going. So you can send it in one direction or you can send it in the other direction. And this antenna The one on the right hand side there currently has burn marks on it because I was woken up at 6 o'clock on Sunday morning with thunder.
Oh, that was.
And I thought I better get in the field and take those antennas down. So I drove up to North Foreland, which is only a few minutes away from me anyway. And there was some rustling in the tent that was up there because we had some of our operators were camping overnight. And I said, I think we should get these antennas down. And there was this almighty crack of thunder, and this voice came out of the tent. Okay. So we came out and we walked up to this antenna, and I had my wire cutters. So what you can't see is on the ground around that antenna, coming out from the base, are lots and lots of wire radials come out along the floor. So just lengths of wire, they're 10 meters long each. There's 64 coming out from the bottom of that antenna in all directions. So that gives us a very good ground plane, very good earth, yeah. Right. And then there is a wire that runs all the way up that antenna, all the way to the very top. It's a fiberglass fishing pole, effectively, 18 meters tall, and the wire runs all the way from the bottom to the top, and that's the bit that actually sends the signal out. So I snipped that wire at the bottom to disconnect it from the antenna system. Pulled it up about 2 inches so it was away from the base, and myself and my friend Steve, we walked in to grab hold of that antenna. And there was this fizzing sound from the antenna, a bit like if you've ever boiled a kettle that's only got a tiny drip of water in it, you get that kind of fizzing noise. There was that. Some steam came off the antenna, and then there was a massive crack, and a spark jumped across that 2-inch gap at the bottom between that element that was on the air and the ground plates. We both jumped back.
That's your two, right?
Yeah. And then immediately grabbed hold of the antenna and put it on the floor. And about 5 seconds after that, we heard the clap of thunder. Yeah. So something that was roughly 4 or 5 miles away, a lightning strike 4 or 5 miles away, produced enough energy in the air for that antenna to collect it. And one of our members on site that day is a qualified electrician, and he was saying that several thousand kilovolts needed to jump that gap. So there must have been 3,000 or 4,000 kilovolts of energy in that antenna
at 5 miles range.
That we grab hold of. Yeah. So we've done the second one rather quickly.
I just said, sod the other pole, I'm off.
Yeah, see you later. Let's go back this way. What else we got? So there's an example of a base station at home. So that's 2 different VHF radios operating on shortwave effectively. One's on 3.5 megahertz, the other one's on 7.74 megahertz. The bottom one is a traditional radio. It's analog, has all built-in filtering, tuned circuits, all sorts of weird and wonderful cool stuff. The one on the top is a new style radio. It's an SDR radio, software-defined receiver, but it transmits as well. So it has everything, pretty much everything is done in software and FGPA arrays and all that stuff. So 2 different kind of beasts there. They both do the same job. One of them looks a bit more fancy than the other.
Just 20 years apart.
Pretty much, yeah, pretty much. Just to show it's for all ages, there's my daughter, age 7, sending data messages via FT8 from a farmhouse in Devon. So we went to Devon for a week last year, and she jumped on the radio and sent a few messages. She doesn't have her own call sign. She uses my call sign. Yeah. And again, that's one of the privileges of being an advanced license holder or a full license holder, is that I can supervise other people that don't have licenses, so they can work underneath my license as long as I'm physically there at the controls of the radio. They can use my call sign and use it.
So you're not having to hold the mic.
You have to. So again, it comes down to the Ofcom definitions. Right. They say that you must be in control of the radio.
Okay. Does that even mean hit the power button?
In control means that you can just reach over and turn the power off as far as I'm concerned. It doesn't mean you have to hold the microphone. The whole point of it is to encourage people into amateur radio. Yeah. So if somebody comes up and says, "Can I use your radio?" and you say, "Well, you can talk, but I've got to do all the cool button pressing." Yeah. It's not really engaging, is it? No. So in my mind, I'm quite happy for them to drive the radio, change things, as long as you're overseeing it, as long as you're making sure they're not transmitting in the wrong place.
So Matt could have a go with our kit today.
Absolutely. Matt could have a go with our kit today. No problem at all.
All right. Cool. There was a question in chat about software-defined radio and analog. If there's difference, what's the difference between analog and SDR? I guess in quality.
Okay. Or not really. I mean, analog used to be the only way to do it until we got things like fast processors and real-time software and things like that. Software-defined, it's a bit of a different beast. It can be, so it's cheaper to do, but at that end of the scale where the cheapness is, it's not as robust as analog is. So if you've got, for example, those two radios back there, if there was a signal very close by or a very strong signal, that SDR radio on top wouldn't work very well. It would receive it. But say I was trying to listen to a signal that was next door to a very strong signal, the filtering in that SDR radio isn't man enough. It's not up to the job. So the strong signals basically wipe out the weaker signals for a large portion of that band. Whereas the analog radio underneath, the filters, because they're all analog, because they're all tuned with proper screwdrivers and stuff, they're much tighter. So better performance. But the more money you spend, the more performance you get.
Okay.
So I mean, those two radios cost about the same. The radio on top is about 900-ish quid these days. The radio on the bottom, brand new, is about 1200-ish. So they're roughly the same kind of class category. But the radio on bottom performs better. But the ergonomics of the radio on top, the display, that kind of thing, is a nicer user experience.
Is it reasonable to say though that the software-defined radio, you could probably do more stuff with it, just because you could change the programming?
Not so much for the commercial stuff like this.
Okay.
ICOM, who make that top radio, they would never release the source code for it.
Oh, so you don't get
you wouldn't be able to just kind of go in and fiddle with it. You've got what they give you basically. But it is easier to update the firmware on them, change the performance characteristics, things like that. So it's much more flexible, because again, it's all done in the software rather than the physical hardware. So if there's an update, it's just a firmware update. Whereas the bottom radio, if they work out there's a fix with it, it's usually a hardware change that you've got to do. So so there's benefits and drawbacks of them all. The major draw that most people go for with the SDR is they have this thing on them called a waterfall, and you can see that on that top radio there, just underneath where it says the 7074. That's what we call a waterfall. So you can physically see the signals coming down there like a waterfall. So and that's across a section of the band, not just the bit you're working on, but either side of you as well. So if you're looking for signals, you don't have to listen and move. You can just see them, and you can tap on the touch screen and away you go. So they're easier to operate. So that's kind of the difference between the two, really. The ultimate and kind of the end game that most of the big manufacturers do is they do a radio which has an SDR kind of front end user interface and characteristics, but then it has a traditional analog style receiver on the back of that.
Okay.
So you're controlling an analog style receiver, but with the benefits of the SDR on the front. And a good example of that is a radio like the Ellicraft K4, which is a brand new radio that's coming out. They've started shipping it, but that's $4,000 off the radio. So you pay for the performance. Given the choice, SDR or hardware, for me, I would still go traditional analog personally, just because that's what I like.
Back when I was operating, SDR radios were starting to become a thing, particularly with controls on Linux, and I was very interested.
That's it.
But it was out of my price range at that time.
Well, SDRs come a lot cheaper, especially for receive only. So a receiving only SDR radio to cover the majority of the radio spectrum, about 25 quid now.
Okay.
Like a USB dongle kind of thing.
RTL, SDR dongles, this picture is an example of a waterfall. So there you can see the signals coming down. They're the peaks that you can see, and so you can see why that's an appeal to people, because they'll just go, right, I'll click on that, and away you go. So that's good. We've got a couple of RTL SDR dongles that are online in Thanet, actually. So we've got an RTL SDR dongle at Manston, at the Spitfire Museum, and you can log into that, and it listens to the 2 meter amateur band, and it listens to the 70 centimeter amateur band. So anyone can log into that online and just use that. And it's another web link for you, which is just trig.org.uk.
Sorry, could you say that again, please?
T-I-R-G. No, T-R-I-G. Trig. T-R-I-G. Which is the Thanet Radio Infrastructure Group.
Yeah.
Which is again something I'm involved in. But it's basically the aim of that group is to put these bits of kit in that others can use. So, so if you go to trig.org.uk, you'll find various links there. So you'll find details about the digital repeater. You'll find details about the SDR up at Mountain that you can log into and view. We've also got a HF SDR at Mountain.
Oh, where's it gone? It's waiting.
What was the RTL?
RTL SDR.
No, what does RTL mean?
So RTL is it's just the kind of the name. So it's a RTL is a reference to the Realtek chip that's inside those devices.
Okay.
Made by a company called Realtek.
Yeah.
They're originally designed for receiving satellite TV on your PC, and then someone realised that actually they're broadband devices, and you can run a bit of firmware on them and open them up and receive pretty much anything you like.
Brilliant. Okay.
So if I was a member of Trig, I could log in and listen to 2 meter radio.
Yeah. So even if you're not
being received at Munster,
even if you're not a member at the moment, you can go to the if you have a look in the equipment, and you'll see Trig 001 in there. I think it's still unlocked because we unlocked it at the start of lockdown so that anybody could use it.
So there's a web-based SDR control panel.
That's it. Yeah.
I think.
And that should bring it up for you.
So we could do a range test on our kit now.
Yeah,
See if we can.
You can literally listen to yourself on
Yeah.
that. We've got a HF as well, which is just now, so that'll be online in the next week or so. Gives you access to the whole of HF 0 to 30 megahertz. And that's 280 foot of wire antenna on it. You would normally a lot of this around.
And spelled up.
Don't know what that is.
QSQL.
Yeah.
That's the
it.
amount of
Really
the gate,
the noise
that the signal has to get over.
Yeah, so SDRs are very accessible these days. And you can buy your own RTL SDR stick, plug it into a Raspberry Pi, run a software called OpenWebRx, and that gives you your own SDR at home that you can log into and control. And there's various plugins that are developed for decoding DMR and D-Star and Fusion and all that stuff. So yeah, it's good fun.
Really?
Yeah, so worth looking at. This picture is something called a nano VNA, and this is another example of how things have changed in the years. VNA is a vector network analyzer, and to have a VNA on your desk in your workshop used to cost you a couple of £1,000 to get something capable. This VNA will give you pretty much the same results as a nice expensive HP, and you can pick them up for under 100 quid these days.
So what are we looking at there?
What you're looking at there, that's plugged into an antenna, and that's showing you the RF response of that antenna.
Okay.
So the frequency that it's being tested at is 162 megahertz, which you can see bottom left-hand side. The span, the physical size of the frequency we're looking at on the screen is 10 megahertz wide, and we can see that that yellow line that comes along is the response back from the antenna. So it's showing us where that antenna is tuned for in the radio spectrum. So it's showing us some other things as well. There's a Smith chart there. It's showing us loss, etc., etc. But the important thing for amateur radio and for transmitting into an antenna is the antenna has to be matched to the frequency you're using. So if I wanted to transmit on 150 megahertz, this antenna would be useless. It wouldn't work very well, and it would probably blow up the radio that it was plugged into if I put too much power into it.
Yeah.
But an analyzer like that, again, in years gone by, you pay even kind of 10, 15 grand for a vector network analyzer. This will do all the way from low frequency right up into the microwave bands, and yeah, 100 quid, even less if you get one of the ones with the smaller screen on. All open source, plug it into open source software on your PC and do all sorts of fun things with it. So yeah, very useful. And where they come in useful in everyday use, for example, I've got a 4G hotspot that we use when we're in these special event stations. We put the hotspot in the field, and we've got internet to the field, so we can do all our online logging, sending our digital cards and things. And a couple of days ago, I purchased a new antenna for it, a new Yagi style antenna. And I thought, well, that'd be cool. I plugged it into my VNA, and where I need it to work at 800 megahertz, because it's very high quality equipment from China, it doesn't actually work there.
Oh, okay.
It's actually more up at 900 megahertz. So again, you can use kit like this to test things that you've got, or to test theories and products and things, and yeah, they're quite useful bits of kit to have laying around.
And as you said earlier, the learning nature of this hobby doesn't seem quite the right word, hobby, but just the tools you get allow you to explore things to a depth and a quality that is unusual for hobbies.
Yeah, exactly.
Really.
I think
It's like an engineer casting steel parts and then destructively testing them to understand the stress response of them. It just doesn't happen. You look them up in tables and
that's it. Yeah, look them up in your handy book. This is a picture of the Manston Spitfire Museum, and that is my mast on the side of it. We wind that mast up; it goes up to 40 foot high, which is as high as we're allowed to go there because of the airport. Even though it's not an active airport, there is still Ministry of Defence equipment on the airfield that we can interfere with if we go higher. There's a high resolution direction finder actually next to the runway, and it works on 406 megahertz, which is the distress beacon for pilots. Right. So if a pilot is down, the distress beacon goes off, and that device at Manston will give a bearing to where that signal is coming from. And they've got them all over the UK, so they get three together, they all give bearings, and they can triangulate where that signal's coming from. No need for any GPS or anything. So we're not allowed to go higher than 40 foot at Manston. But that has a big Yagi antenna on it. The antenna at the very top is a vertical antenna, and that's the antenna that the SDR radio is connected to. And then the big Yagi antenna, we use that for contesting. We meet up, 3 or 4 of us meet up once a month up at Manston. We sit in a camper van, plug a radio in, and we annoy the French by calling CQ. So we work in a contest every month.
So that Yagi is pointing towards France.
That Yagi, where it is parked at the moment, is pointing. I think it is southwest. Or is it southeast? It's pointing southwest. I think.
Is it on a rotator?
It's on a rotator. Yeah. So just underneath it, you can see there's a kind of a large lump of steel at the top of that mast, where all the cables seem to go into. That's a rotator, which is basically a big turntable we control remotely to point that antenna in the direction we want and push all of our signal in one specific direction. Just underneath that, in line with the roof level, there's another small antenna on the side. That's an I always get it wrong, it's the aircraft tracking software, ABSP.
That's ships, isn't it?
No, it's the ships is AIS.
AIS, okay.
And ABSP or ABSD is the aircraft tracking software. And there's a website called Radar 360 or 360 Radar. I don't know which way around it is. There's a chap who runs that called Philip, and he built the whole thing himself. And I've got one of these at home. Yeah. And, I contacted him and said, "Hey, I've got a really high site next to an airport that might open at some point in the future." And he said, "Great, I'll send you some kit." We plugged it in, the way to go. Brilliant. So that feeds live traffic data from aircraft into his network. It displays it on a map, so you can track where all the flights are and stuff. The interesting thing about his network is that it also tracks military traffic, which is good fun. Okay. Now, military planes, they don't give out their location, obviously. They fly around, they don't give out their own location. But they do send out a beacon. So they send out a squawk, effectively, saying, "This is the plane that I am," but they don't tell you where they are. And Phil has developed this network of receivers that uses MLAP, which is effectively triangulation, and it can work out where those flights are in real time. So you can pull up his software and you can see where the Chinook has gone and where it's heading. So it's quite fun. So, yeah, he hasn't been shut down yet.
No,
so
they don't really care. They're not that worried about it.
They don't care because they do shut it off when it becomes important.
Yeah, but if they need to, they'll obviously turn that off. So
that's true. Yeah, they won't do the beacon.
Nothing active beacons, does it?
No.
All the training flights and stuff do. So it's quite interesting when you get a Chinook come over here or something. You can fire it up and see where it's come from, where it's heading towards.
Really interesting.
Yeah, it's quite interesting stuff.
It's the same with the ships as well. I mean, military ships have.
That's right.
AIS. I keep getting it wrong. They can switch that off.
AIS and military ships, if you're interested. Which is so AIS is effectively a blind transmit. Okay. So it's a transmitter that just says, "This is the name of my vessel. This is where I'm going. This is where I've been. This is how fast I'm travelling." Some of them say what cargo they've got on board. Some of them say the draft. So it's just spitting out the details of the vessel. Okay. All commercial ships over a certain size have to have AIS. Okay. to avoid them to broadcast their transmission. And they have receivers on them as well, which tells them where all the other commercial ships around them are. So it's kind of a collision avoidance system.
Yeah.
Okay? So AIS is on ships, apart from the shore stations. And there are several shore stations in the UK. And there is one shore station not very far from where we are now, not very far from where a lot of my other kit is, which is controlled by Border Force.
Okay.
And what happens is Border Force use that shore station to spit out the coordinates of where their vessel is not. So when you load up your AIS and you go, oh, the Border Force boat's over there,
Yeah.
they're actually sitting over here, but they're transmitting their data from up there, and they're spoofing the signal. So it's an interesting use case for it, and yeah, quite a clever way of
They're
doing
hiding themselves
it. They're hiding themselves.
by
So
doing that.
their ship's not broadcasting, but their shore stations are,
Yeah.
but they're sending the wrong data. Because they actually are sitting here when they're, you know, creeping up behind you.
But with an SDR, you can spoof that kind of data yourself as well.
Yeah, I mean,
quite
if you
easily, can't you?
if you were experimenting, I mean, you start going into the interesting side of the hobby, but you can use SDRs to do all sorts of fun, nefarious things, you know, including spoofing GPS and things like that, which is something that's been done by the Russians quite openly. You know, they'll spoof GPS coordinates and spoof GPS satellite signals.
Yeah.
So your GPS locks onto it and goes, "Oh, I'm here," when actually you're over there. So yeah, it's interesting stuff. Yeah, it can all be done. And if you know, if you get your amateur license, or even if you just read the books, you'll get a basic understanding of that kind of stuff, and you know, more appreciation for the kind of things that can be done.
I could do buy a new copy of the advanced book just to have a little browse through.
Here's another interesting photo. So as part of the club that I belong to, we're quite an active club. I'm the treasurer of the club. I've been the equipment officer for many years. But as a radio club, we often get asked to get involved in things and interact with things. This is it used to be called the Marlow Academy. I'm not sure it's the Marlow Academy anymore, but it's the home of Academy FM, the local community radio station. They had an antenna on top of that mast, which was the wrong antenna. It wasn't an antenna they were licensed for. They were having transmission problems, and they got in contact with us, and we spoke to them, and they said, "Do you know anything about radio?" And we said, "Well, funny enough." And we went up there. We decommissioned their old mast. We tested all the cables for them. And we reinstalled this antenna that you can see going up there for them. So if you're listening to Academy FM in the Isle of Thanet, you're listening to it being broadcast from an antenna that was put up by our radio club to help them out as a community station. So, you know, we like to try and get involved in things where we can, where that expertise is useful. In fact, I'm going up there next week to realign their sky dish for them. So because that's been moved. So there's just a couple of our club members on the roof, all harnessed up with their hard hats on, doing their thing. I was supervisor, so I just stood back and had a cup of tea. So. And then I think my last one. There we go. This is a nice one. This is what actually happens when your antenna does get hit by lightning.
Right.
So this is what we call a masthead preamplifier. So this was up at Manston on the mast at Manston. And the job of this piece of equipment is basically to take the incoming signal from the antenna, amplify that signal up, make it louder, and then squirt it down the cable back to our radios. And the reason we put them at the top by the antenna is because we want them to amplify just the stuff coming in from the antenna. If we put them down the bottom by the radio, they would amplify any noise or anything that the cable's also picking up. So we just want to amplify signal. So that was sitting at the top. And that took a almost a direct hit. We reckon it was about 500 meters away. We think it hit the original radar tower at Manston, which is the big square tower. If anyone's ever been near Manston, it's quite a big square tower that's near it. We think it hit that, and that's the damage that it caused to that. And that's basically a lightning surge coming in. It's quite crispy. But again, with the knowledge and the information that was imparted on to me by studying, we fixed that device, and it's still in operation today. So
that's a pretty robust kit.
Despite the fact the circuit board had a hole in it.
Same plate as well. Just it's like a wall in.
We left the burning on the lid. Just the memory. But we repaired that. But that's the kind of damage lightning can do. So it's all fun and games until you get hit by lightning. There you go. Just a few pictures I thought I'd share.
Wonderful, thank you.
Great stuff.
I joined British Aerospace back in 1997, and one of the first jobs I worked on was JTIDS, which was Joint Tactical Information Distribution System, and it's on military aircraft. It's a data link to share stuff, data obviously, but they had a JTIDS aerial on the hangar, and me and my new boss got to drive up and down the airstrip at Wharton near Preston, to go into the DME and the TACAN sheds alongside the runway to measure the signal that was being transmitted by the JTIDs to see how the DME and TACAN aerials would, what residual kind of signal would appear there, to check it wasn't going to interfere with them. And it was I'd only been working there for about a week. It was such a treat being driven around by air traffic control with 2 Hawks doing touch and go practice kind of things, where they land and then take off straight away. And we were waiting by the runway. A Hawk came down and did the touch and go, and then the ATC guy drove at full pelt down the runway to the first shed.
Yeah,
we did the stuff in there with the jets going, screaming around outside. We got back in the Land Rover, waited for the radio to say go, and went screaming down the runway again. And it was so exciting. And all this talk about the radio stuff we've been talking about tonight just brought that back to me, and the exhilaration of doing radio stuff, actually. And, just driving down the runway because we were looking at this interference thing. It was a wonderful start to a otherwise dull career.
I found that the radio knowledge, it crops up all the time. Like just knowing a bit about radio, and I don't think I know that much about radio anymore. He's did me advanced and everything.
You'll be surprised at how quickly it all comes back.
But there is. You'll be looking at a problem. You go, this feels like something you understand, and it really helps to understand electronics and things like that. So it's the same as I started doing electronic design and stuff like that. It was a point. I don't know if you remember me, Matt. We have met a few times over the years. Yeah, that's right. But so I used to work for a company called EMS in Herne Bay, doing radio fire alarms.
Yeah, you just Don.
That's it. Yeah, John and Don.
Do you know Don?
Yeah, GKR. Yeah. So John and Don were the guys I mostly got me into radio and stuff like that. And John, I built the Morse transmitter for John's slow scan TV repeater. So he got me doing microchip pick stuff, and that sort of led to a job and lots of things like that. But it was the bit I really sort of started to understand more was that when looking at electronic circuits, we think of things as square waves. We're turning on digital signals on off, so 5 volts or 3 point whatever volts and stuff like that for signals. And it was when the owner of the company, he wanted me to sort of think not as things as just on off, but as in loads of radio waves. Don't think of or loads of electrical waves. Don't think of them as on off signals, but think of them as lots of different waves going down together. And so, do you remember, if you do a fast Fourier transform of a square wave, you'll see that there's the main sort of fundamental, and then you'll get the third frequencies going down. And it was starting to think of it as a signal being on or off as that, and then you can look at the electrical circuit, and then you can start to understand all the filtering that's going to occur in your circuit just through residual capacitances and inductances and stuff like that. And it was from doing radio stuff and starting to understand filtering that suddenly you could see that stuff going on in what are apparently digital circuits, but as soon as you start getting high-speed digital circuits, or if your digital circuit is then actually connecting to a radio transmitter or a radio receiver, suddenly you really care a lot about analog aspects of digital signal movement through a circuit and stuff like that. So I just think it just keeps cropping up in all sorts of places that unexpectedly, but really helpful. And so it means that you get to look at a problem slightly differently to people who haven't messed around with radio, and you get to sort of imagine currents in a much more sort of fluid way. It gives you this new visualization of how stuff's working. Yeah, it does. You know, I do with programming as well. You know, I sort of see programs in a weird visualization way, and I think I get it a bit with circuitry as well.
But I did do a project for an artist, and I'm really feeling that I was just floundering around in the dark, just trying things, and eventually it worked. But it was in Greenwich Foot Tunnel that goes under from obviously Greenwich under the Thames to the other side, and we installed, I think it was 10 media players and speakers on the ceiling of the tunnel. And he wanted them all to play the same thing at the same time. So he got in touch with me and said, "Can you do that?" And I always say yes, and then figure it out later. So I started off with some cheap 433 megahertz kind of transducer kind of things attached to an Arduino. But that didn't give enough range. So then I changed to HC12 with just a piece of wire cut to the right length. And that worked. We could get the mothership in the middle to say go, and they all received that wirelessly, and they went. But all of the ranges and the power and all of that kind of stuff, I never really had a full understanding of it, or even a close to getting started understanding, because I just went for trial and error and got it working. But they say these things should have this amount of range and that amount of range and that kind of stuff, and it's never like that, because that's in the perfect scenario.
Real world's never like that.
And I still wonder, how complex is a tunnel with a steel case and people walking up and down it with phones for those transducers, and what was about the context that was important that I didn't really.
So I've had experience installing radio systems in tunnels, because obviously if you're in an emergency vehicle driving through a tunnel that's on fire, you probably want to be able to use your radio in the middle, don't you? So there's a couple of big tunnels in Kent that we did, and we always use a system called a leaky feeder, which is an antenna, but it's a piece of coax cable. So effectively, it's the cable that you would normally use to attach an antenna to a radio. You put a fake antenna on the end of it, so the radio thinks it's transmitting into a proper antenna, and then effectively you just cut chunks of the outer shielding of the cable off. So your signal, a bit like a leaky garden hose, it just squirts out along the length of that cable. So you run the cable down the length of the tunnel, and suddenly you've got perfect radio coverage inside the tunnel. You don't have to worry about reflections and going around corners and things. And there's plenty of tunnels in Kent that are,
because everything's suddenly close to the transmitting point, I suppose.
Sorry?
Everything's close to where the radiating.
Exactly, as you drive through the tunnel, you're always in coverage, basically, because you're driving right next alongside the radiator. So so they're very good.
Sure, I remember someone doing a talk at Hillstone about using leaky feeders as a security device. I think the situation was, imagine two long wires, maybe like several meters apart. The top one is a leaky feeder, and the bottom one is a receiving antenna.
Oh, okay.
That's it. And so you might be sending a carrier, transmitting a carrier through, and your receiver will then receive that. But as people sort of come into the vicinity, they sort of interfere with the signal, and therefore the carrier being picked up, it might shift phase or something like that. I don't know if shift frequency, but it'll shift phase. Something will happen to it. And so your receiver can then detect that shift and just say, "Oh, there's something there." You know, I don't
somewhere
know.
along the entire.
So one of our members is a security guy, and he's involved with. He used to work for Chubb, and now he works for a smaller company that's quite a specialist company, who do some very specialist jobs. But one of the products they use is called GeoWire, and that works on the same principle. It's buried under the ground,
Right. Okay.
and it transmits a magnetic field, and it's got a receiver that receives that magnetic field. And as somebody or something moves into that field, it causes distortions in the field which pick up on the receiver.
Okay.
So the alarms go off before you've got anywhere near the fence, basically, because they're detecting that, and you can change the sensitivity so that it doesn't go off for foxes or rabbits, but will for a large child. So yeah, it might have been that you came to talk, because you gave a talk on that.
So that wouldn't have been, well, I guess. So there's a magnetic field.
Yeah, magnetic field, but still radio. Because radio waves have an electrical portion and a magnetic portion. So, and one of the other things that that it's surprised a lot of people don't know, because you can't really visualize it, is that you see in the books that a radio wave kind of does this. It's like a sine wave, isn't it?
Yeah.
But if you're looking at it from the end, it's rotating as it comes towards you. So it's doing that 360-degree spin. So it's not just going up and down like that as it comes towards you. It's going up and down as it goes around the compass. It spins round. So it's rotating in all the dimensions, basically, which is hard to visualize on paper.
Is that because you're seeing not only the electrical field but the magnetic field?
You're seeing the magnetic field as well. Yeah.
So, and because what they're 90 degrees
cross-polarized and they spin.
Yeah. So you could say as one's going up, if you could see like the locus of the join, I guess. Yeah, I can see that. But otherwise, we have polarized antennas for reception and stuff. But that's because we're only really concentrating on the electrical field at that point. Yeah. So the electrical field is either it's moving in one plane, one way or the other. But yeah, it's a combination. So that was the way I always used to imagine it. I think it was probably Ken Smith was explaining it to me once. Was that you are sending an electrical field, or an electrical signal, electrical field up to your antenna. And so if you think at the point of the antenna, that changing electrical field, this is my dipole. We're still recording. Okay. All right. This is my electrical field going through my two arms of my dipole, and they are generating a magnetic field. Which then, let's go forward a bit, which then induces, I should have said induces, not generate. That induces an electrical field, which then induces a magnetic field, and that's radio. It's this.
And to complicate matters, you can receive either the electrical field or the magnetic field.
I didn't know you could pick up. So it's a magnetic antenna.
Oh yeah. So I have where I live in the hotel. It's quite a noisy environment electrically. Lots of TVs around. Lots of people turning hairdryers on and off.
Yeah.
15 people plugging in their cheap Chinese iPhone chargers. So generating lots of electromagnetic interference, lots of noise. But that noise is mostly electrical noise.
Yeah.
So I have an antenna in my garden, which is a loop antenna. It's basically a 1 meter circumference metal loop, and that's connected up to an amplifier, which amplifies the magnetic portion of the radio wave. So I'm listening to the magnetic portion, not the electrical portion, which means I don't hear all of that noise and rubbish. So I can hear signals that I wouldn't normally be able to hear because they're masked by all that electrical noise. So that's a magnetic loop antenna, and you can build them for receive only, or you can build them to transmit as well. So you can transmit on the magnetic portion, but as we know, every magnetic portion has an electric portion, and vice versa. So it doesn't matter if someone's transmitting using a conventional antenna. I can still receive the magnetic portion of their transmission.
So we're not worried so much about the hairdryer generating its electrical noise, because it's not really a transmitter in the same way. It's sort of sending static everywhere. So there used to be things called spark gap generators in the early days, which basically just blatted out across, because they were sparks going across. Remember that square wave? Square wave is just full of frequencies, if you like. That's what the spark gap generators are doing. So I guess that's what the hairdryer's doing. If they're not brushed so much anymore, but if it was a brushed motor, we'd be seeing sparks in the device. So that doesn't really generate a magnetic field. So
you're listening.
Because I can't imagine actually how do we detect a Hall effect transmit? I suppose is it essentially like a Hall effect pickup or something like that, or is it a coil? Is a coil?
It's usually a coil.
So you're detecting the change in magnetic field into a coil.
Or so the one I have, a whole bunch of JFETs that are daisy chained together.
Oh, okay, so this is like the coil like one trying to do with the harmonic.
Transistors, and that's it. So that's what you're doing. So yes, very very smart.
Wow.
It means that if you're trying to operate in an electrically noisy environment, you have a chance of doing it by listening to the magnetic portion of the wave rather than the electrical portion.
I never thought of that. That's brilliant. That's fantastic.
Yeah, and they're quite often used to. So we never used any when I worked in commercial, because we worked on the police side of things. We never really played with HF.
Yeah.
But other organisations in the UK that still operate on HF and probably always will due to the dependency, you'll find that various state buildings, if you look at them, some of them will have these weird metal circular loops on the roof, and they are magnetic receive antennas.
Is it
So-
a single piece
Like
of
a hula
metal,
hoop.
or is it actually
Like a
a
hula
coil
hoop.
of wire? So it's not. Is it a coil of wire inside it?
No, it's just like a hula hoop.
Oh,
Just
and
a
one
round metal hoop. That's it.
on one coil.
That's it. Just a single turn. Some of them you get shielded ones, so it will the loop will effectively be made out of coax cable,
Yeah.
and the outer will be earth, so they're shielded
Yeah.
because the magnetic wave will pass through that, but the electrical wave will hit that and be effectively filtered to the ground.
Yeah.
So you get shielded ones as well. But they're in use by many government agencies, embassies in foreign countries have them on the roofs because they still operate HF radios for that kind of thing.
It's cool home.
So, well, yeah, exactly. So, yeah,
That's
interesting
brilliant.
stuff, isn't it?
Sorry, I just
deep.
really like
Such
that.
a-
You know,
Again,
never
just
thought of a
just
magnetic
another
arrow.
facet of a hobby
Yeah.
where you can get
That's
really
it.
deep involved in.
See,
So-
you should do it, mate. You should do it.
Antenna
I
theory.
don't know how anyone could resist. Tonight.
Well, I often find myself saying to people, even if you don't care about radio, even if you don't want to talk to anyone, even if the idea of being licensed to use 400 watts on effectively the Wi-Fi frequencies, because we've got a frequency that's right next to the Wi-Fi channels that we can do Wi-Fi on at 400 watts.
Yeah.
Even if none of that excites you, if you get the book and just read through the book, you'll come out of it with a much better basic understanding of electronics and radio theory, and real kind of, and that helps in all sorts of different projects and things.
Yeah.
So what would be a good book to buy?
So
if you
there's a series of books produced by the RSGB, which are effectively the training manuals for the license. The first one is called the Foundation, and the second one's called the Intermediate, and the third one's called the Advanced. So if you just search for RSGB Foundation, you should find the little Foundation book, and it's basically a manual for how to play with the radio effectively.
I think Matt should get his foundation license. You can do it.
I think Matt should get his foundation license.
Yeah,
I'm
do it,
an
do it.
RSGB assessor, so
Okay.
we can hook you up with a test. No problem at all.
Well, it's
I'll put you in for next Tuesday.
how many
When
pages?
I did my foundation at Herne Bay, and it was a Saturday. We just went over for the Saturday.
Yeah.
And the club over in Herne Bay, they taught it, and
Yeah.
then I guess it was an exam, but I think it was a multiple choice
Yeah,
exam.
it's a multiple choice tick box
That's
exam.
it. Yeah, and it was nice and easy because you can't, for the foundation, you can't build your own kit. You can't mess around. You have to buy. Or once again, my knowledge is 10 years out of date, so I keep saying what I think the rules are, but
No, you're pretty much there.
you have to buy like CE marked equipment, and it might be quite marked equipment.
Yeah, the foundation, you have to buy approved equipment.
Yeah.
Or you can use equipment that has been built by a full license holder and certified by that person. So
Okay.
you can buy a kit at foundation level. You can buy a radio kit. You can solder it and build it yourself, but you mustn't use it. And then you can give that to a full license holder who will use it on air and test it. And then they will sign their call sign on it and give it back to you. And now you've got a piece of kit that's been approved.
So you could still build something.
You can
from
build
scratch.
something, have it tested, and use it. That's perfectly fine. At intermediate level, you're allowed to build your own equipment and start experimenting with things. And you get a power limit of 50 watts, which is a decent amount of power to use.
Yeah.
And then if you go full advanced, you can pretty much build what you like, where you like, and do what you want.
And go overseas.
And go overseas.
Yeah.
I did obsess for quite a long time, like, a couple of weeks on and off, really, but on the rules and regulations around putting transmitters in a public place like Greenwich, and I felt that I felt confident enough to just go ahead and do it.
Yeah.
But those regulations in those bands were nowhere near that power at all.
So standard 434 license free 433 is, I think it's 100 milliwatts and
Something
I
around
think
that.
it's something like 10% duty cycle.
Yeah.
So for every minute that you transmit, you're not allowed to transmit for the next 9 minutes, like 10 or 10 minutes. Whereas for amateur use, there's no such thing as duty cycle. You just crack on with it. So, and it's a bit like, I mean, we don't have any frequencies in 800 megahertz area, which is where most of the LoRaWAN stuff is. But down on 433 and 434, that's kind of our allocation. So we can use LoRaWAN kit, and we can run it through amplifiers. We can put a 400 watt base station up if we like, rather than the 100 milliwatts that you're allowed license free. So we can do all that kind of stuff.
But so this job for an artist, I wouldn't have been able to use amateur radio frequencies because it was a paid job.
Because it was commercial gain, yeah.
But the leaky feeder, are you able to run a leaky feeder at low power, or do you find that the power gets lost like halfway down the tunnel?
Absolutely.
So that power stuff that Matt was worried about, the leaky feeder would probably reduce the power usage even more.
So the whole point was that we couldn't run cables down the tunnel at all.
Okay, all right, then fair enough. Right.
Otherwise, they would just have a cable going along.
Yeah,
You need lasers, and more importantly, sharks.
Sharks with lasers.
So I've just put that sticker on that enclosure there, warning, sharks with freaking lasers right there. But my first idea was to use IR, and then within seconds, I thought that's because I had to take them down every day and lining them up.
Okay, all right.
Then I moved to radio in 433 and then HC12.
What having an understanding would have done for you is it would have told you that there would be frequencies that would be better to use in a tunnel than others.
Like tuned.
So
yeah.
So it's a bit like you'll often see like little handheld walkie-talkies that you get, and you'll see it used at events and things where they're coordinating. They usually run on UHF, on ultra high frequency, 400 megahertz ish, and that's line of sight. And it's very good. It offers very good voice quality, but it's line of sight. You can also use VHF a little bit lower down. Still very good voice quality. Still line of sight.
Penetrates better.
Well, the thing is that the higher in frequency you go, the more affected it is by things like moisture. So you could take your VHF radio into the forest, and you could take your UHF radio into the forest, and your VHF radio would give you better coverage and better range because it will penetrate through the trees and the foliage better than UHF will. UHF will be distorted and absorbed by the moisture in the trees and things. Whereas you can take your VHF radio into an urban environment and take your UHF radio into an urban environment, and you'll often find the UHF will perform better because VHF will effectively pass through things like glass quite easily. They get attenuated, but they pass through. Whereas things like glass and concrete, UHF radio waves tend to bounce off them rather than pass through and be absorbed. They bounce off and go different ways. So you'll often find better coverage in concrete infrastructure with higher frequencies to an extent. When you go too high, it doesn't work anymore.
But 5G is a bit reflecty and
5G will bounce off a fair bit of stuff. But but your answer about the leaky feeder is that with radio, you have this inverse square law. So your power coming out of an antenna diminishes with the inverse square law. So you end up, you can transmit 400 watts over here, but 10 meters over here, it's much less power.
Than another 10 meters.
Exactly. Whereas with a cable, with a coax, you don't have that major issue of inverse square law. You only have the loss that's induced by the coax. So you only have the amount of power that is being lost by that coax. And no cable is 100%, no loss at all. Some are better than others. The higher in frequency you go, the bigger cable you need.
So it only turns to an electromagnetic loss when it gets to a leak.
When it actually gets propagated from the antenna, that's it. So your 100 milliwatts going into a leaky feeder will still be, 10 milliwatts at the other end, because you're only losing a little bit through the coax. So it's not quite the same as, you don't need to run hundreds of watts into a leaky feeder to get better performance for a distance. So,
I had some interesting conversations with this artist down the tunnel because he's a sound artist, and he in the past has done installations where he's created sound waves in a space that you could feel. as you walked through, for example.
Ah, yeah.
And it's very similar to that idea of electromagnetic waves and how it's affected by the tunnel. I don't think we quite got to the point of, I wonder what frequency is tuned just right. But we were, and that's Whisker away from it, because he tunes his audio frequencies
for the environment,
to have the points of interference and working within the space to be able to feel that as you move through it.
I mean, you would have also been able to
lots
do
of
things
similarities.
like you were cutting pieces of wire and putting them on your modules as the antennas. If I was doing something in a tunnel like that, and I had a device in the middle that I wanted to send that way and that way, I would probably build a little power splitter to split that signal into two separate signal paths, and then I would put them into directional antennas that pointed either way. So you're using the most.
Are they spiral?
Yes, you can use a spiral kind of a helix antenna, or you can use a Yagi, which is like a TV style antenna, because that way what you're doing is this antenna here, for example, the signal is coming out of this on all sides like a sphere, the same power all the way around. Now, if I'm just talking to down over here, all this power is wasted.
Yeah.
So if I could put something here that reflected all that signal that way, I need to use less power, and he's going to hear me better. So in a tunnel environment, that's ideal. You know, you split your power so it's going both ways, and you shoot it both ways, and therefore your receivers can have smaller antennas that aren't particularly efficient on, because your transmitter is doing all the heavy lifting and focusing the power where it's needed. And having a foundation license, or even having read that book, gives you that kind of understanding that you can do that kind of thing. You know, rather than just cutting bits of wire and going, yeah, that'll do. You could have you'd also know the calculation for working out exactly the right amount of wire for the frequency you were using.
Yeah, well, I did do that bit.
Oh, you done
with
that?
the wavelength.
Yeah, work out the wavelength and then cut the antenna for a quarter wavelength.
It was, yeah.
Super, perfect, yeah.
Yeah,
I
got to that point, and I started going deeper into the antenna. My Google searches were all about antenna design and that kind of stuff, when I should have just typed in our foundation thing with a GB or whatever. I can't remember. I've already forgotten. I should have just done that, and then I'd have been laughing. But
yeah, and I think the other thing is that you can go to Google and you can search for stuff, and there's a wealth of information out there. But having that basic understanding, you can look at something, and within a few minutes, you can actually go, yeah, that makes sense, or you can just go, no, that's complete rubbish. No, that's complete, and discard it, because you'll often find things that are on. I mean, we get this in the amateur community, is that you get people that are experts, and then you get people that are experts, and you'll often find that experts and the experts disagree. And I get frustrated sometimes, because I'm commercially trained. So I did my telecoms training with an organisation called Ray Castle, which is, have you heard of Ray Castle?
No.
They're pretty much the best telecoms training provider in Europe.
Right.
They're based up in Ambleside, and I cut my teeth learning mobile networks, and because the police sent me up there to train me for the new generation that they've moved over to, Tetra and Airwaves and stuff.
Yeah.
So all this stuff about inverse square law and different modulation techniques and all that stuff, I learned that, and I had to really soak that up and pass that, and then you come onto all on the internet, you come onto a forum and someone's going, oh yeah, well that's how that works, and you're just like, that's not how that works. That's not how any of this works. But you can't have those debates with people, because obviously people know. So having that kind of basic understanding of how stuff works, you can look at those arguments and you can go, yeah, that's maybe not quite right, and you can kind of pinpoint it. So
I have had training in sort of radar systems and that kind of stuff. I worked in avionics for a long time, doing R&D kind of stuff for avionics. So you kind of have, it's a bit peripheral, I suppose, but part of the bigger understanding. And the MSc in particular, we got down to calculating, what range could a Nimrod sense a submarine's mast sticking out of the water at a meter, and it was a surprisingly long way.
Yeah.
But so I have had that experience, but I've completely forgotten. now, but maybe there's some residual kind of
you
mental
find
models
some
stuff
Yeah,
in there
there'll
somewhere.
be similar
Maybe.
theories there. So it'll
Maybe.
be
Most,
very interesting.
in my experience, most people with no understanding, no prior knowledge, nothing, can pass the foundation by studying for about 2 weeks. Then after that, they'll pass. People with a good understanding of prior knowledge, or people that understand what a sine wave is, for example, 1 weekend is done. That's it. That's it. I done my foundation course. I sat the course on Saturday. I sat the exam Sunday morning and passed 100%, because it was, if you've got that basic understanding of what an electron is and how things move around the circuit, then you're set basically. And the intermediate just dives into a bit deeper, and the foundation and the advanced dives right into it.
I'm visualizing rows of carrots popping up in front of me.
It's a good thing to have, yeah. I think, and not a lot of people have got it, in terms of the general population.
But yeah, I'm quite I am wondering. I'm quite interested in IoT because it's the next big thing kind of thing. And LoRaWAN and Sigfox and all of that, the old TV kind of band kind of thing. I've done a bit of stuff in that kind of area, a little bit, and we're working on a project that's using Zigbee network.
Okay, yeah.
So I've got some Zigbee hardware there that I'm trying to sort of stand up just a three node network. And I feel a bit in the shadows because I don't have the depth of knowledge that perhaps I know I don't need it, but I feel like I should know more about it.
Well, we talked about perhaps we'd set them up with aerials, and don't we? And then we need to figure out what size aerial.
I'll show you the aerials on these things.
I might have to head off soon, gents.
Yeah, it's.
Okay, yeah. So is that 868?
That's 2 gig, I think, was it?
Is that a Zigbee, isn't it? So yeah, it's 2.4 gig, isn't it?
Yeah.
Just
so I think we know we've got high bandwidth with it, so then we've got the propagation issues of.
Yeah, that's a 2.4 gig dipole.
Yeah, I think I bought
the track from it.
Just going to try and turn
a tune circuit in it. Cool. I've never played with the Zigbees. I've played with the RFM 12s and the RFM 69s, and
similar.
LoRa I've played with quite a bit.
Yeah,
I've got a mini LoRa network at home,
Okay.
so it's not connected up to the internet, but I use it for. I built it to monitor our fridge and freezer temperatures.
Yeah.
So
it's for a business, so you need to make sure
we've got
everything's fine.
That's it. We've got.
These are the HC12 modules that I used for that.
Oh, that's it. Yeah, just the standard. They're standard on-off keying ones, aren't they?
Or can't remember.
Yeah.
But these are the aerials that came with it. But
Okay.
and that's the same length as the straight bit of copper that I used for the aerials in the end.
Do you remember the VHF frequency at Manson?
The
VHF frequency at Manson.
the
2 meters. 2 meters. You said you had a 2 meters.
the SDR.
And
2 meters. 2 meters and 77 at distance.
Do you remember what frequencies?
Any frequency you want.
Oh,
you
of
put it
course.
up.
All right then.
So it covers the whole 2 meters.
Okay,
So
let's go.
if you put up 145 450, for example, that's an FM voice frequency, and then you put it up on the SDR, you should hear yourself on the SDR.
Can we go to that website? I mean, I don't know. I used to get quite good range.
It's where to go with it. In here, it might be a bit of a stretch.
Yeah, I
it's
wonder
where to go.
Could get an extension cable and set it up outside.
Meat Lotion has said he would like to go for his intermediate, but he'll need to refresh everything.
That's fine.
He did his foundation at Dover.
All right, we won't hold that against you.
Right, you want the SDR thingy. Right, the volume's up.
So the exams now, you don't have to go and do them anywhere. You do them at home.
Oh, okay.
Now, you download the software. It's called Test Reach. You can do a practice exam on there.
Yeah.
And then when it's time to do the exam, you fire up the software. You get an invigilator who watches you via the webcam,
Yeah.
and you do the exam, multiple choice.
RSTV
And you find out whether you
download.
passed or failed immediately.
Brilliant.
Radio Society of Great Britain application
So at
download.
the moment, the exams at home are mandatory. You don't have to do them at home. You can come to a test centre. So if you don't want to do the exam at home, you can come to the Hildestone Club, for example.
Yeah.
And you'll have a local invigilator, but you'll also have a webcam invigilator as well. You can come to a test centre and do it.
Yeah.
But it's got to be done online. It's got to be done.
So it'll still be
PC
online, even though that you're
Yeah.
sat somewhere.
All of the paper exams are gone
Yeah.
because of COVID and lockdowns and all the rest of it.
That makes
And
sense.
I think the examination board decided they were too expensive and it was a lot easier to do it by software. So so you can come and do it and do that. Yes, the software works in Windows. I don't think it works on Linux or Mac.
But yeah, you could always borrow one.
But you know, our club, for example, has Windows laptops with the software on that you can use for the exam. So
Okay.
I'm just answering. Who's asking the questions? Wheat lotion.
Yeah.
Excellent. Answering the questions. That's that's RM3.
Would anyone like a drink or anything like that?
No, I'm okay, thank you.
Can I have a coffee? No, have water. Water. 145.50.
Our chat would like a tea, please.
A cup of tea?
Our chat would like a tea.
Oh, I'll pour it down the microphone. I've got lemon squash.
Oh yeah, that'd be nice. Thank you.
If you want to come and do your intermediate, send me a message and I'll get you on the path to doing it. And we'll provide everything for you, make it nice and easy. The more the better.
Right, I'm just going to bring down the squelch just to see if I can get anything through.
I just thought I could use my microphone.
So you're on SDR at Manson.
There's someone else transmitting there at the moment. Thank you very much. I'll bring the squelch back up.
If someone else is, they're transmitting from this.
So that's just the receiver.
Yeah.
Only ever receive, which is why we can open it up to everyone.
Yeah.
Right. There's a funny thing in the UK about listening, and that is that you're only allowed to listen to services that are either license exempt, so traditional radio and the shortwave broadcast bands. Something we call PMR 446, which is kind of kids walkie-talkies from Argos. You're allowed to listen to them, so they're license exempt.
Yeah.
You're allowed to listen to any of the amateur frequencies. You don't need a license to listen to them, and that's it.
Okay.
Everything else you have to be licensed for to listen to.
Yeah.
So you know, even if you want to, so this radio here, for example, it's got the marine VHF channels on it, so I can listen to marine VHF.
Yeah.
Technically, that is a breach of the Wireless Delivery Act. Technically, it's a criminal offence. However, for me, I hold a marine VHF license, so I'm safe, mate.
Yeah.
But you know, people do listen to the marine channels.
So that's undetectable,
They
isn't it?
listen to the aircraft channels.
You can't
they listen to
detect
all
what
stuff,
people are listening
but
to.
it's all illegal. A lot of people used to think that the rules were you could listen as long as you didn't tell anyone.
Okay.
You could listen as long as you didn't tell
Well,
people what you were listening
I could rob a bank as long as no one
Don't say
finds
that.
out.
No one finds out, yeah. And that is still a common misconception in the UK, that you can listen as long as you don't act on the information. And people like the Coast Guard, for example, they run a social media campaign occasionally saying, you know, don't tell people what you hear, because they know people listen,
Right.
and they don't really care that people listen, but they don't want you hearing that the Mary Jane yacht has sprung a leak and is sinking and there's 3 people on board, and then phoning your mate and they phone their mate and they happen to know the wife of the guy that's on board, so they phone her and go, yeah, your husband's nearly dead. You know, they don't want that going on,
No.
which is understandable.
Yeah.
So but they don't say don't listen, they just say don't share anything you hear,
That's right.
even though technically you're not allowed to listen.
You should be listening.
So exactly, yeah. So the SDR, for example, is locked to the amateur bands
To stop people listening
stop
to
people
others.
listening to anywhere else, but you can listen to somewhere else if you know how to do it. So you know, if you're that way inclined.
So why can't we hear anyone speaking on the SDR.
They were a moment ago. They probably just stopped transmitting. Really try. So
Can you see?
M0LMK listening. I can't see anything on the waterfall.
So you've got the waterfall up,
Sit down.
and you're. Well, you've got a
145,450.
145,450.
Yeah.
145,450.
Helps us
So
find
this
it,
is the.
Sorry, wrong band. I was trying to
So this is the RF spectrum.
M0LMK receiving.
There's your signal just coming in there. Is that tiny little line? That was you. That was you. Very weak, but that was you. So this is the whole spectrum here, from 144 megahertz up to 146 megahertz. We're looking at 2 megahertz of bandwidth. This is interference. This is a signal that's coming in down here, very low. That's probably an image from a different transmitter. This is data coming in here. This was a voice transmission here.
So that'd be the person we heard probably just as we.
That's probably the person you heard. Yeah, that was a voice transmission.
But they've got a.
And this.
I'm trying not to say proper aerial data.
Yeah, they got a proper antenna.
Yeah, they've got an extension lead. Outside.
And this portion here, where that yellow marker is, that's the portion that we're actually listening to. So if we unmute it and turn the squelch down, that's the bit we're actually listening to. So you can see the activity that's going on, and you can move that up and down to listen to various other bits.
Yeah.
And away you go. And then this section here, if you drop that box down, it'll give you a choice of different bands to listen to, where you change the block of frequency that you're listening to. So this SDR, this can support 4 users simultaneously, but you've all got to be listening to the same chunk of spectrum. Right. So if we move it now, the other person who's currently on here, because there's 2 people on here, the other person will move with us whether they like it or not. They might move us back. So, so yeah, it's a bit to and fro.
Can we see exactly what they're listening to?
You can't see what they're listening to.
I think I might have taken them away for camping, but let me have a check.
We've got to see if we can get a signal up. I'll just stand there with it.
Hold it up. Hold it in the sky.
Otherwise, do I have the?
I was playing with one of my friends a couple of months ago, and we were sending each other text messages via the SDR, because there's a couple of digital modes where you can send signals across the spectrum. So they're spread spectrum modes. Yeah. So you can write text on the waterfall.
Oh.
So we were sending each other messages looking at the SDR. I'd send him a word, and it'd appear on the SDR, like come down from the top and appear as it transmitted across the spectrum. So yeah, that's quite fun. Good. Yeah.
That's like I know corn circles.
Oh, okay,
and writing and stuff.
That's it. Yeah, spread spectrum is quite fun. Because unless you were watching it on an SDR, you'd have no idea it was there.
You wouldn't know.
That's it.
I'm guessing we're out of luck, Matt.
I've taken them away. I'm afraid.
An experiment for you to do later at home. There you
That's
go.
right. Yeah.
Now you know where the SDR is.
Double check the website. That'll be on the
truth.org.uk.
Yeah.
That's it.
I've got 2 sockets in here. It's still not enough. I thought it would be enough.
It's never enough.
Still need a bloody extension.
I found my Allen key in here as well, so I'll put your ones back in there. So, and I will start packing this away and try to clean up all the muck that came.
Is this full?
Should all be in there now. Very cool. It's been nice to sort of remember some of this stuff.
Keep an eye on the Hillstone Club page.
Yeah.
On the website, and come along to some of our special event stations.
Yeah.
G4. Yeah, old school. Old school. There we go. I don't know when our next special event is. We're restarting club meetings.
Oh yeah.
In September. So So we'll be up at Durban. You know, we moved to Durban Road in Margate.
Oh, so
We used to be up at Hillston,
Yeah.
up at the tower.
yeah.
And now we're based at the Scout Hut in Margate, which is, do you know Draper's Mill?
Not really.
Okay,
I know the area.
There's a footpath around the back, isn't there?
Yeah.
As you drive past the hospital, you come up to two small roundabouts.
Yes. Yeah.
So you go right at the first roundabout, right at the second roundabout,
Then you head down.
and then you go down the big hill.
Yeah.
At the top of that big hill on this side of it, the hospital side, there's a Scout Hut on the left-hand side.
And
That's where we are now.
Oh, okay.
We've got our own, so we have 24/7 access to that whenever we want.
Oh.
We've got a dedicated room there that we use as a club shack that we're just finishing off building. So club members will ultimately be able to get the key and use that equipment whenever they like, so long as the scouts aren't there.
Yes. What's the agreement with the scouts? Like occasionally you let them use the kit as well, or something like that?
Well, we maintain the site for them.
Oh, okay.
So we're effectively their gardening club.
Yeah.
So we go along every 6 to 8 weeks with the strimmer and the ride-on mower and cut the grass for them.
So they're quite
And
happy.
they get a nice maintained site, and we get a shack that we can use that isn't in use any other time.
Powered and watertight.
Powered, watertight, secure. We pay them a small amount of rent, the rent. So
Yeah, but you also then not having to break everything down.
that's it.
Exactly. Yeah.
Exactly.
So that's when I was at Hildstone. We had cupboards in places.
That's it.
But everything had to go away.
That's it.
Yeah,
So
so-
go back away. Whereas now we have the shack. And the nice thing about having the shack is that when we were at Crampton Tower, we had one big room. And in that room, you'd have 20 people broken off in groups of 3 or 4, all having a chat with themselves, and it just got so loud and noisy. But also, if you were doing some training, so you might have someone coming in, might be only their first or second time, they might want to play with the radio a little bit.
Yeah.
You'd suddenly have like 15 people you didn't know staring over your shoulder, looking at what you were doing.
Yeah.
You
They're
know,
really
like-
interested, but it might be a bit unnerving.
nervous. So now we've got the shack. What we can do is we can go, let's go into the, and we can close the door.
Yeah.
So it's just you and somebody else, you in that. Earning.
Meatloaf should ask another couple of questions.
Is there possible for anyone to recreate this for their own use? If so, how? Recreate what, the SDR? Recreate. Yes, the SDR. Excellent. Yeah, sure. So you just need an RTL SDR dongle. So you need an RTL SDR stick, and the best place to get that is rtlsdr.com, I think it is. rtlsdr.com. I've got to be careful spurting out random domain names.
Yeah.
Matt types them in and bring them up live. I think it's rtlsdr.com. We'll pop the page up. They do an RTL SDR stick, which is it provides you HF, UHF, VHF, and it's got some extra filtering in and stuff. It's a little bit more expensive than a normal one.
Does this page look right?
It looks like it, yeah, it looks slightly different than that, but I think it might be the same site, but just a redesign.
By tuners?
Yeah, that's it. So buy SDR tuners, go for that. And they should have so there's a whole bunch of information on there about different ones you can buy and things. But yeah, you basically just need an RTL, that's it, rtl-sdr.com. There we go, Meatloaf's got it. That's the one. So there's a whole bunch of information on there. You can get the device from a company called Technofix in the UK. They sell the RTL SDR stick, Technofix. You just search for that on Google. You should find that. That's it, top shot result. There we go. And then if you go into SDRs there, USB RTL SDRs, that's it. There's a silver one. That's it, top right hand side there. So that's the official RTL SDR stick. It's a touch more expensive than the normal ones, but it is a very stable, very good stick for the money. Really, really good. You pop that into a Raspberry Pi, and you run OpenWebRx, or you can run SDR Shark, any of the SDR web applications or any of the local SDR applications, and away it goes. Job done. You tell it whatever frequencies you want it to run on, and happy days, you've got yourself your own networked SDR device.
I'll share all of these pages together.
Have a massive link then. Yeah, it's very good. I use one at home, and I use it to monitor the marine band at home. One of the other pies that I have my fingers in is I do a bit of marine VHF repair work. So I fix marine VHF radios and do the occasional install as well. So I like listening to the marine band. I've got another one that monitors airband, which is quite fun. That's right, yes, what's that? There's one in Folkestone, which is used to monitor marine traffic in Folkestone as well. I'm not allowed to share the link for that, but that's a link to the Folkestone group that they have up. If you're a licensed radio amateur, then there's a website called Kiwi SDR, and on there you can join that website with your amateur call sign. I think you have to provide them a copy of your license, which you can easily download from Ofcom and upload to them. But that then gives you access to hundreds of remote SDRs. There we go. So it gives you access to all of those SDRs all over the world. They were locked for a while. Are they unlocked now?
Let's try this one in Western Australia.
Load up. Yeah, there you go. So yeah, perfect. So it was locked for quite a while, where you could only access it if you had an amateur call sign. So you had to register on the system. But now it looks like they're unlocked. So that's Kiwi SDR. And typically those are usually HF SDRs, on the shortwave and long-wave bands. But they work very well. We've got one of these up at Manston, which will be online in the next week or so. What are the upper and lower frequency limits for the RTL SDR? I think they're about 200 kilohertz up to about 1.5 gigahertz, I think. They're pretty well unlocked. There's no kind of blocks in the middle that are stopped or locked, like a lot of the US stuff. But yeah, they're very, very broad. Very broad. Again, if you search RTL SDR frequency range, you'll come up with the results for it. So yeah, you can get 27 78125 on there, so you should be able to. On the Trig SDR, no, you can't get that on the Trig SDR. Not the one that's currently active, but you will be able to get it on the new one that will be online in a week or so. So you'll be able to get 10 meters and 11 meters on that with no problem.
It says 500 kilohertz to 1766 megahertz.
Oh, there you go, yeah. So 500 kilohertz to 1.7 gigahertz. So pretty wide.
Or direct sampling mode, you can go all the way up to 24. Or stay down at 24 megahertz. Anyway, yeah, so.
Oh, yeah, 24 megahertz in direct sampling mode, yeah, just the way that you pick the data out of it, basically. These are really cool devices. So RTL SDR, who pioneered this device, they brought out a new device last year, which was called the Kerbos SDR. And it's basically 4 of these SDR devices on a single board with a noise source, so a way to generate noise, and an onboard clock. So you can synchronize all 4 up together. And some of the applications you can use for that, which would interest you, are things like radar. So you can set these things up to receive RF, and they'll work as a passive radar system, which is quite cool. I've got one in the shed which I haven't taken it out, it's wrapping yet. But one of the things on my shelf, but I'm going to use it for direction finding. So you can put 4 antennas on it, and it detects the phase shift between the signal coming into the antennas, the time difference of arrival, and it will give you a bearing towards where a signal is coming from.
Oh, excellent.
So one of our long-term plans is, so the GB3EK repeater, for example, it gets a fair bit of abuse.
Yeah.
So one of our plans for that was to mess around with ways to mitigate that abuse. And one of the things we came up with is that if you could have an antenna system that you can control.
Yeah.
So mobile phone technology, they use phased array and beam steering. So they focus the energy wherever you are, effectively, and they move the beam to focus the energy. So if we could bring that across to the amateur hobby, and you could build an array of antennas on a repeater for the receive side of the repeater.
Yeah.
So the transmit would be all over, but the receive, if you could form a beam so that it provided sensitivity in the direction of the user, and effectively put its fingers in his ears for anything else, then you could use that as an interference mitigation. So the first person who transmits, the DF system works out where they are, feeds that information into the receiver and the beam steering, and you have 8 dipoles or probably 8 Yagis, and you use those Yagis to provide directivity in the direction that you want, and effectively a null to the other directions. So it's just a theory that we're working on, might be quite fun.
Yeah.
So and there's no other license that you can hold that allows you to play with that kind of technology and do that kind of thing. So it's just another facet of the hobby, really.
So how fast does the direction finding work with the phase array? It must be pretty quick.
Oh yeah, milliseconds.
And when we talk about beam steering, are we actually talking about physically moving stuff?
No,
it's electric. So it's switching things on and off.
So basically, it's switching antennas in and out.
Yeah.
So if you had an array of 8 dipoles in a circle, you could switch in phasing lines to the rear dipoles or to the dipole that you want the direction to be in.
Yeah.
So that you are pushing gain in that direction and providing
destructively interfere in the other side. Okay. Yeah.
So you can,
you get phased array radars as well.
Yeah, same kind of concept.
So instead of a moving gimbal, it's a fixed plate.
That's it.
Covered with little triangular antennas that beam steering, so there's no moving parts in the radar.
That's it.
Very cool.
So it can move a lot faster than a big
gimbal. Yeah.
And I mean, we've got 2 DF sites in Thanet that are up and running, which are quite good fun to play with. Which are using older DF equipment, but we can those 2 DF sites, we can move them frequency. They're frequency agile because they run on SDRs.
Yeah.
So we can run them on 2 meters or 77s. They suffer reduced performance on 2 meters, but they still work. And those DF sites will give us a bearing from the site to a detected signal.
Yeah.
So if I wanted to know where G4MHU was, I can log into those SDRs, I can put them on the frequency that he's on, and when he transmits, those DF sites they effectively push the coordinates at the moment to a Google Doc.
Yeah.
So on the Google Doc, it will come up with the bearing from triangular station 1, triangular station 2.
Yeah.
And then you could take those bearings, plot them on a map, and get 2 cross lines to roughly where he is. With a third, you get real decent, accuracy. So our plan for Thanet is to have 3 or 4 DF stations up where we can start doing funky things with targeting receive for certain areas.
For your troll.
Or if you can combine that with a drone that could drop a bag of slime or something.
Yeah.
Well, unfortunately, we do get these trolls that appear in amateur radio. Yeah. And unfortunately, I'm saying that Ofcom are quite lax in enforcing any of the rules. And unfortunately, that's the same for that at the moment.
But if you could give Ofcom the information that person is here.
You'd think so, wouldn't you?
Oh, okay. So you know where they are already.
But well, in March last year, the way that Ofcom works is if there is an interference complaint. Say you are using the repeater for which I am the license holder. Okay, so say you're using EK, for example, GB3 EK.
Yeah.
You're using it. Someone's blocking you out. Okay. You can't complain to Ofcom.
You have to complain to you.
You have to complain to me.
Yeah.
And I have to complain to Ofcom because I'm the license holder.
Yeah.
Okay? So it was March, not last year, March 2019. I've been submitting interference complaints to Ofcom for 6 years. Okay.
Right. Okay.
I make it nice and easy. You go to the GB3EK website. There's a page on there to report interference.
Yeah.
You fill it out with all the details you can. That comes through to me once a week. I have an automated PHP script that runs, it takes those PDF files, it puts them in an email, it sends it off to Ofcom as an interference report.
Yeah.
Okay. I've sent over the last 6 years about 700 interference reports to Ofcom. Okay. Always the same thing happens. Thank you for your reports.
Right.
Okay. The case has been opened, automated email. 30 seconds later, your case has been closed, automated emails. Okay. Because
Okay.
they're not interested in prosecuting. However, back in March 2019, I've done my usual thing, sent off this report, but I noticed that one of the reports was an abuse report, an interference report for GB7TH, which is the digital repeater, and that had never received an interference complaint before. But they all just got wrapped up and sent off anyway.
Yeah.
And then a case was opened, so there I was waiting for the email to come in for the case to be closed, and the email didn't come. I just thought, well, it's probably, you know, lag in the email system or something. About 2 hours later, I get a phone call from the duty engineering officer at Bulldog, which is the Ofcom monitoring station.
Right.
That's where they're all based now. And they'd opened an interference complaint into the digital repeater. So I spoke to them about the complaint. I spoke to them about how it was linked to the analog repeater, and that the majority of the complaints are actually about the analog repeater. And he said, okay, we're going to open a case. I was like, okay, that's great. He said, I'm going to send you the paperwork, and we'll do an investigation into it. Fantastic, lovely. I've still got the paperwork in my email. Now, that paperwork arrived with me, and Ofcom were willing to investigate, but I had to agree to a personal liability of, I think it was £140 something plus that per engineer per hour if they found the interference to be of something that was under my control.
Oh, okay. Yeah.
So if they found the interference was a faulty part on my repeater or something else. Now you could argue that users of the repeater are under my control because I facilitate the repeater doing what it does. So you could argue that if they found it was someone else causing it, that's still technically under my control because I control the receiver that's taking that unwanted signal.
Okay.
You know, but you'd be into kind of semantics in there. So I duly signed the paperwork.
Oh, you went for it? Okay.
Oh yeah, I signed the paperwork. Yeah,
Okay.
I thought, the opportunity doesn't come along. 6 years I've been submitting these.
Yeah.
Never have they been interested. So I signed the paperwork, and I sent them what could only be described as a treasure trove of information. Okay, I have been outside of our abuser's house.
Yeah.
With a spectrum analyzer. Okay, with a real old spectrum analyzer, a nice bit of kit.
Yeah.
Measuring signal strengths while recording audio recordings of the abuse taking place.
Yeah.
Okay, which isn't, unfortunately, in this case, it isn't always just keying the radio and trying to block people out. It is things like name calling and copying people. We've got a user on our repeater who is partially almost blind.
Yeah.
He practically can't see, and he's got a speech impediment. So his only contact with people on a regular basis is through this repeater. And he'll come on and he'll stutter a little bit, and then our particular abuser will come on after him and go, there.
Yeah.
Now, to me, that's harassment.
Yeah.
I mean, that's. I mean, you could even go as far as discrimination. So I've got voice recordings of this. I've got video footage of a spectrum analyzer recording the input frequency of the repeater.
Yeah.
On that video recording, in the same shot, is a GPS showing my exact locations. Okay. So you can be pretty damn sure that that signal is coming from somewhere very, very close by. Okay. I've got video footage of that, followed up by getting out of the car and showing the camera a big amateur antenna system.
Yeah. Yeah. Okay.
With a big antenna on it pointing directly at the GB3EK repeater. Okay. It's conclusive proof, right? I've got all of that. I've got a massive spreadsheet detailing the dates and times that this abuse happens. I've broken that down and analysed it to show the probability of when this abuse is going to happen. So I know that it's going to happen before 10 o'clock in the morning, because that's when our morning guys come on, and that's when they get abused. And I know it's going to happen after 6 o'clock in the evening, because that's when this abuser is finished his work shift for the day and he comes home. Okay, so I know when it's going to happen. I sent all that information to Ofcom. They sent me back and they said, we're going to send an engineer down. I was like, great, fantastic.
An engineer?
Send an engineer down. Absolutely amazing. Because despite what I've sent them, they can't use that as evidence. They can't use it. Because I could have had a mate sitting in this guy's front garden with a radio transmitting.
That's right.
To stitch him up. So they can't use it. They can use it for information, but they can't use it for evidence. So they sent an engineer down, and I got a phone call about 1 o'clock in the afternoon on a weekday. Hi, I'm the Ofcom engineer. I won't share his name for his own sake. So I'm parked up at the bottom of your repeater.
Yeah.
I can't hear anything. That's because you're at the bottom of the repeater in a van.
Yeah.
In the middle of a weekday when this guy is not around. That's why you can't hear anything. He said, well, I'm listening on the output and I can't hear anything. I was like, well, immediately you need to be listening on the input.
Yeah.
You need to be listening to where the signal is coming from, not when it's leaving the repeater. You need to hear it coming into the repeater. Oh, okay. Well, I've got to go home now. I've been here for an hour. I'm going home. So he'd come down, spent an hour here listening to the wrong frequency and left.
Okay.
Came back about 3 weeks later. This time it was about 2 o'clock in the afternoon. This time he was parked up by Manston because I've told him that was a high point in the area, so that would be a good place for him to park. He said, I'm parked up here. I'm just trying to work out how to use a spectrum analyzer. Okay, you're an Ofcom engineer. You should know this thing. You know, you've got tens of thousands of pounds worth of kit in your van. You should know this stuff. So it's been a while since I've had to do any RF work. Okay, that's great. Send an engineer that doesn't really do RF. He's a licensed amateur.
Oh, okay.
Yeah.
That might be a bit me.
Gets better. So again, didn't hear anything. Okay. So he came back about 5 or 6 weeks after that. He duly explained to me on the phone that I wasn't a priority, that my case was the lowest of the lowest cases. So if another case
not
came
for you,
in,
though.
yeah, he said if another case comes in, you know, it gets bumped. Instant priority over yours. You know, so if anything happens, you might not hear. He said, in his words, you might not hear from me for a few months because we'll be busy.
Okay.
But you know, rest assured, we're working on it. So he came back, and he said, "Oh, I've been." He phoned me and he said, "Oh, I'm leaving." I said, oh, "Okay." And he said, I've been somewhere called Blean." I was like, "Okay, fine." He said, "I've heard some interference on the input." I said, "Great." And he said, "So I've recorded the interference. So I've witnessed it now.
Yeah.
So there's definitely interference on the input." And he went, "I'll be back, leave it with me." I was like, "Okay, fine." So then kind of COVID came in, all the lockdowns came in.
Yeah.
And then in, I think it was probably June last year, I got a phone call from him saying, okay, we've gone as far as we can go. We're closing the investigation. I was like, okay. I mean, you were parked 100 yards from this guy's house.
Yeah.
I mean, I spoke to him at length with him, and I said, you know, did you see any antennas? And he said, oh yeah, I saw a big mast. I said, did you see any Yagis on it? And he went, yeah, I saw some Yagis on it. And I said, was there anything that struck you as a bit strange about those Yagi antennas? And I'll give him his credit. He said, yeah, they were vertically polarized. Normally with Yagi antennas, amateurs polarize them horizontally because we use single sideband on them, and everyone transmits horizontally. It's just the convention, okay? And this particular antennas were mounted vertically, and the only reason you'd mount a Yagi antenna vertically is if you were using FM and you wanted to get it a long way, or you wanted to get it a very strong signal. Okay. And he said, yeah, they're mounted vertically. And I said, did you notice which way they were pointing? And he said, oh yes, I've made a note in my log, and they appear to be pointing directly at your license repeater. And I was like, well, isn't that funny that you're parked somewhere where you've witnessed interference, and there's a big mast with big antennas pointing directly at the box that's being interfered with, and there's nothing else in that location that's visible that could produce a signal that strong to be able to wipe out those boxes. He was like, well, I'll go away and do my investigation. So anyway, he phoned me back up and he said they're closing the case. And I said, well, why are you closing it? And he said, oh, I can't, you know, we're just closing it. I was like, well, why are you closing it? And he said, oh, I can't really tell you why we're closing it. We're just closing it. And that was it. That was my interaction with Ofcom. So
they could have just gone and knocked on this door saying, excuse me, can I talk to you about your area? I'm from Ofcom, and that might have put the field gun into him, and he would have
stopped. As I explained to the lovely engineer, who didn't really understand his statutory powers, I said, you have a statutory power to inspect. So when you take your amateur radio license, when you apply for your call sign, you are giving the licensing body, Ofcom, the explicit authority to enter your station whenever they like, with no reason to do an inspection. Okay, so Ofcom can literally knock on your door and say, "We want to see your radios right now," and that's it. They can walk in and inspect it, and they never use that power. Right. And I said to him, all you've got to do is knock on the door and say we're investigating an interference complaint, and that will stop it.
Yeah.
But I said, what you've effectively done is you've gone hunting, you found the person, you've walked away, and news will get out that you've been hunting and that you found this person and that you've walked away, and that will just empower them to continue.
Yeah.
Because they'll decide that they're untouchable, and that's exactly what's happened. They've gone away, they haven't brought any cases forward, and that's it.
Do the RSGB have any sort of
the
opinion
the
on
RSGB fighting our corner?
That's
right.
That's right. So
the RSGB put out a call about 3-4 months ago from the chairman of the RSGB, Len, saying that he wanted information about any abuse that had been happening, things like that. So I sent him all of my documentation, sent him all of my interactions with Ofcom. His response was, "Oh no, I didn't mean that type of abuse. We can only get involved in abuse where there's been a police complaint."
Oh, okay.
I was like, that's fine. That's absolutely fine. Because one of our users was harassed so much that he submitted a police complaint. And I've got the prime numbers. And what happened with the typical efficiency of the police is that he submitted the complaint. He provided my details as somebody who could help them with their investigation. But somewhere along the lines, my email address got replaced with his email address, and the officer in charge of the case emailed me all the details of the case.
Oh, okay.
I was like, thank you very much, but it's not me that you should be sending this confidential information to. But I spoke to the officer in charge, who explained to me that they were dropping the case through lack of evidence. And I said, well, you haven't even attempted to gather evidence because you've not attempted to contact me.
Yeah.
And I've got video recordings, audio, GPS coordinates. I've got all this going on. I've got recordings of this guy saying, "It's a good job I don't know where you live because I've come and put my shotgun through you." Right? And the guy who is saying that holds a shotgun certificate.
Oh, okay. Right. So they could...
Now, in any sane world, a firearms officer would go, maybe it's time we review this guy's certificate, wouldn't you?
Yeah.
But no, the police said lack of evidence. And they said they contacted Ofcom, and Ofcom refused to help. So I went back to Len and said, it's okay, I've got a crime number.
Yeah.
Here it is. And that was about 6 weeks ago, and I've heard nothing from him since.
How frustrating.
Yeah.
Yeah.
And the RSTV just aren't interested. They either aren't interested because there is political friction between them and and Ofcom,
right?
Or there is a lack of political friction between them and Ofcom.
What, they're getting along too well.
Yeah, maybe.
It makes me want to go around to this house and accidentally remove the aerial.
Oh yeah. I mean,
take it away.
He's an interesting character. Do you know who it is?
No. I mean, I think I remember. It's been going on when I was on radio.
So this particular person has been going on for a decade.
Yeah.
He's in the nicest way possible. I think he needs more help than I could possibly provide for him. I think he would probably need a specialist.
Yeah.
He was recently convicted. Do you know about?
No.
So he was recently convicted. It was a relatively quiet case because it was convicted under the breach of the Official Secrets Act.
Oh.
He was working at a army barracks as a contractor. And the only reason I know about this is because my brother is in facilities management, and my brother was the FM at this particular base. So he was looking after the base. And he was prosecuted because he was found to have installed wireless cameras inside the barracks. So there were cameras in the plant room.
Yeah.
There were cameras in the canteen area where they all ate with the contractors. They weren't in any of the military, like where they weren't in the any of the military areas.
Yeah.
They're in the areas that the contractor's going to, but officially it's an MOD site.
Yeah.
And he was found to have installed surveillance equipment unlawfully on MOD property.
That's pretty fucking serious.
It's really fucking serious, yeah. So the case went to court very quietly, and he was prosecuted under the breach of the Official Secrets Act, which he had accepted by working on those premises.
Yeah.
So that's the kind of person that
Isn't he in jail now?
Well, no, unfortunately not. Suspended sentence.
Okay.
Well, he won't be able to work.
His reasoning was that his reason why he did it, and I don't know whether to believe him or not. I mean, I could understand that if you are perhaps of a certain state of mind, you might think this is a good course of action. His reasoning was that his co-workers were talking about him behind his back, and he wanted to get evidence of them doing it before he went to see his boss about it.
Right.
Because his boss knew nothing about it.
Right.
So his defence was that he was recording them talking about him behind his back, so that he could then present that evidence to his boss and have them all fired. So that was what his reasoning was. But yeah, he got a suspended sentence
and fired, I think.
And fired fairly quickly. Yeah.
Well, that was probably the right thing to do in that particular case. Really, I mean, it does sound quite.
But the interesting thing is that so the way repeaters work is they're licensed, okay, but they're licensed to an individual. That person is referred to as a repeater keeper. Okay, so I'm the keeper for that repeater. There used to be a different repeater for that keeper. It used to be Don, T4 TKR, and Don asked me if I would like to take it on after him because he'd had enough of managing it. He wanted to do other things. So I took the repeater on. About a week after I became the keeper, and that documentation was all published, and it was made public that I was the new keeper, my brother phoned me up, and he said, do you know such? And gave me a name. Yeah. And I said, no, never heard of them. And I said, oh, okay. Because he knows you. I thought, what do you mean he knows me? And he said, he came into my office today, and he asked me if you were my brother. And I was like, okay, that's a bit random. And that is the person who is the main...
The troublemaker.
Yeah, the main inspirer. So, so all these little pieces of the jigsaw all fit together, But, I'm moaning about Ofcom not enforcing stuff, and I'm moaning about this particular guy destroying this particular piece of infrastructure. But I don't want that to sound, I don't want it to put a negative spin on the overall hobby, because overall,
most people
it's a hobby, the majority of people, it's like
consideration.
Anything, you're always going to get the one idiot driver on the road.
But compare that one person to doing something on the internet.
Exactly. So it's a negative side effect, but the majority of the hobby is a lovely hobby to.
But also, it showed that you use technical means to gather your evidence. Okay, the evidence didn't get taken any further, but it was another opportunity to flex that sort of radio muscle and learn
a bit more of them.
Yeah, that's right.
Exactly. Yeah. So, and part of that experience has driven us to think about ways that we can make the infrastructure more resilient to these kind of attacks, if you like. Which is why we're thinking about DF. I mean, one of the reasons we built a DF array was so that whenever this interference happens, we can ping it up on a Google map. Yeah. And say, right, we know it's coming from there because that's where it's telling us it's coming from.
That's right, yeah.
So we can now pinpoint.
Effectively, passively jam it by perhaps ignoring that.
Passively desensitize the receivers for that area. I mean, one of the other things that we trialed for a while, which we might roll out actually, was we did voting receivers, which were quite fun. So that is an RTL SDR stick attached to a Raspberry Pi with a small antenna.
Everything good starts with a Raspberry Pi.
Everything good.
Everything.
Attached to a small antenna. Yeah. And we gave one to our most prolific victim, if you like, who used to get targeted all the time. We gave one to him, and he plugged it in his house. And what it does is it listens on the received frequency for the repeater. Yeah. Okay. And when it hears a signal, it pushes that signal over the internet to the repeater, and then the repeater ignores its local receiver and takes the signal from the voting receiver. So when you're sitting in your house, you transmit, the signal near the receiver nearest you receives it first,
And it's because it's so close.
pushes it up to the internet, and the repeater then ignores any other RF input and only listens to the input from that receiver. And so if you decentralize your receiver, and instead of being on a high spot, you've got lots of less sensitive receivers covering less range dotted around. Those receivers make you instantly immune to those jamming attacks, because unless that person is in the same room as you or in the same, half a kilometre as you, they won't be being picked up by that receiver, and therefore the system will just ignore them. And that's a system that's used on commercial systems quite a lot.
Brilliant. So it just means you have to have the internet as that other channel of communication, but you have it now. It's there. So
you also don't have to have the internet.
Because
we're amateurs, we can do an uplink on a different frequency. We can do private 5.8 gig links. We can do 2.4 gig wide area. So we can use lots of different means of getting that signal back to the voting receiver.
So you can use the internet as a quick way of proving the idea, and then you can introduce other sorts of links.
Other elements for links to make it area dependent.
Real.
So, but it's those experiences it's the issue of jamming that has made us look at these different methods and doing it.
Try and find a solution.
Excellent way of turning a negative into a positive.
Exactly. It's a way of overcoming technical challenges, basically. So there's a lot of stuff you can do with it. And I quite like the voting receivers. They're really nice because it's 50 quid for a Raspberry Pi and an SDR dongle. Anyone can either buy one, or we can have volunteers have them at their locations all over Thanet.
That's it.
And suddenly you don't need a receiver up there at all.
But so you still want the height for the transmitter.
You still want the height for the transmit.
But just for the receive.
And the voting receivers roam as well. So for example, if there was one at the bottom of Margate High Street and one at the top, and you were on a handheld radio walking up Margate High Street, when your signal was stronger at the one at the top, that one would vote in and your signal would be received from there instead.
Brilliant.
So it follow you around as well. So the only time it doesn't really work is if you're in a vehicle and you're driving quite quick. You can get a little bit of interference as one drops off and the other one comes back. So apart from that, it's pretty good.
This is a problem that mobile phone networks deal with, handing off between phones. And they just practiced it for a long time.
That's it,
and refined it.
So this vertical Yagi transmitter that the jammer is using, does that produce like a cone shape beam, or is it a parallel?
No, think of it like so Yagis produce something called gain. Okay, so your standard antenna, your standard vertical antenna, let's say it has 0 dB gain. Okay, and then every 3 decibels is effectively a doubling of your power. Okay, now an antenna to produce gain, it has to lose something. You can't produce it out of thin air. So imagine a beach ball. Okay, that's the radiation pattern you get from a normal vertical antenna. Okay?
Just a straight
beach ball is coming out in all directions in a sphere. Okay. Now, if you introduce some gain into that antenna, you need to lose something. And with a vertical antenna, you generally lose the top and the bottom. So now imagine you're squishing that beach ball down, and the more you squish it, the further out to the sides it's going, but the less it's going to the top and the bottom. Until eventually you end up with a frisbee, which is a very high gain vertical antenna. You're squirting it out towards the horizons and nothing to the top and the bottom. So you're not losing anything, but you're not gaining anything. You're just pushing it in different directions.
The energy that was going at the top and bottom, you're sharing it out in another direction. That's it.
So a Yagi antenna is exactly that. You're putting your vertical, and you put a reflector behind it. So stuff is hitting this and coming back. So you're losing less energy out the front, so you're getting gain. And then you put things in front called directors, which are effectively shorter and shorter as you go down, which then focus that energy in. So if you look at a Yagi from the top, the beam is very narrow and pointy. You have a little kind of lobes on the side, a little bit at the back, but it's pushed in one direction. Imagine it a bit like a torch. And you shine a torch beam, you get a little spill out the side, don't you? But your main focus is at the front. And the more gain you have in general use, more gain, the thinner that beam is, the narrower that beam is. So there's ways to avoid that. So you can stack antennas on top of each other, which will increase the gain without changing the beam pattern.
Okay.
So you can have, when we do contesting, we stack 3 big Yagis on top of each other, and we phase them all together as a 3 stack, and that gives us more gain, but it gives us a wider beam.
Yeah.
So that if I'm talking to you, I don't have to turn the antenna to talk to you because you're still in the beam width of it.
Yeah.
So we want the gain, but we also want a decent width beam, so we don't have to move and.
So you said this guy flips his Yagi antenna into the vertical.
Yeah.
So that reducing kind of cross piece thing would be pointing up into the sky.
Yeah, the directors are and the actual radiating element as well.
So they'll be pointing up.
Yeah.
No, they're point. So when you
well, a standard TV antenna normally it's horizontally polarized.
Yeah, so standard TV antenna is normally horizontal like that. So this is the driven element, and there's lots of other elements coming towards you. Yeah. When we say vertical, we mean it's been mounted like that.
Oh, right. Yes.
So all the elements are still facing you, but they're in the vertical plane. So all the energy is still focused where it's pointing, but that is hardly. We don't use that.
You're talking about roll rather
than pitch. Yeah. Roll rather than pitch.
Oh, right.
And we don't use that in general. We don't use Yagis vertically on 2 meters or 70 cents. It's not the standard convention.
Yeah, it could be, but
it could be.
I've never seen a TV aerial mounted.
Well,
like
actually,
I was the wrong aerials then.
Yeah, so I've got a loft aerial pointing at Dover, and the signal's not great, but I believe there is another repeater in Margate.
There is.
Yeah, which is vertically polarized.
That's
so
right.
I should be able to take that same antenna, turn it, and then do that. And then I should be able to.
Interesting RF fact for you. Yeah. Margate and Dover is an experimental site for Freeview.
Yeah.
And Dover transmits on a certain set of frequencies, and it transmits horizontally.
Right.
And Margate was the first ever station for the Freeview network where they experimented with frequency reuse but opposite polarization.
Right,
so the repeater station at Margate, which is on top of Invicta House, funny enough, has a vertical antenna on it.
Yeah.
Right.
So if you point your TV antenna at Invicta House and turn it vertically, you'll pick up the channels from Invicta House.
Yeah.
We haven't got an antenna. We haven't got an antenna in our house anymore. The previous people, when it changed to digital, apparently just gave up and just we got an aerial guy to come around, and he looked at the cable and said, "Oh, that can't do digital," and he went away.
Oh, okay.
So we just used the internet to watch telly, and we haven't thought about it since.
Yeah, if it works.
But it's a little bit annoying.
You can use the same cable to do digital.
I thought that was a bit weird.
Yeah, there's no difference in the cable.
But the longer I've lived in Margate, the more I realise that sometimes these experts don't necessarily speak.
It's just slightly different to what he's normally seeing. And,
they used to call the Margate transmitter they used to call it the Margate infill because it only provided a certain number of channels.
Yeah.
But
and for quite a small area.
That's
as well.
Yeah. 2 years ago, they done quite a lot of work up there. They replaced the antenna and they installed more multiplexers in there and more muxes. So now that is a full.
Yeah. So really, we should be using it.
You should be pointing at Margate.
Yeah, because it's going to give us a much better.
So if I get,
but I also need to buy a new aerial because I've got like a bog standard B&Q one, which is just wideband.
Yeah.
And I think in this area of the country we're quite down the band for digital TV.
Yeah.
I think so. I should really get an aerial which is tuned for that area.
So the aerial that's just been lobbed into our loft is just hanging around. If I get that and point it in the general direction of Invicta, compass bearing or something like that,
mount it vertically,
and
then it should be
connect it to the existing coax.
Yeah,
that will.
Pick up from Invicta House. Yeah.
Well, look at me.
Yeah. I know the RF engineer that works on Invicta House, a guy called Mark, and he works for Akiva, and he's a really nice guy. And he phoned me up and he said, "I've got a problem up in Invicta House." I said, "What's that?" And he said, "Our GPS keeps losing lock." I said, "Okay." And the reason that's a problem is that all of those sites are GPS controlled for the time, not for the location, for the time.
Okay.
Because they transmit multiple signals on the same channel, and they multiplex. So
time division.
Yeah, time division. So at this half second, this one's transmitting. At this half second, this one's transmitting. And so they need to be really accurate, bang on time. So they have GPS receivers and they do all the time via GPS. He said, we keep losing GPS log. I said, okay. And he said, the problem is we lose GPS log and the system shuts down. It just stops transmitting.
So also avoid mistransmitting.
Yeah, because what happens if it mistransmits is it causes black holes in the coverage and move around.
Yeah.
So at 1 minute this location hasn't got any signal, then that has no signal, and that has no signal. So he said, what we do is we shut the whole thing down so that it all goes black. So we don't get people going, oh, it's working, no, it's not working, no, it's working. So that's what they do. And he said, can you come up and turn off some of your kit? Because we think it's outside interference doing it. I said, okay, no problem. So I met him up there, and he opened the door of the cabin, and sure enough, after about 30 seconds, GPS lock disappeared, gone. I was like, okay, that's a bit weird. And he said, yeah, it only happens when we open the door to the cabin. And I was like, okay, well, that's obviously something external coming, because the cabins on the roof are all metal shielded, grounded, very well done. So that's obviously something going in. And he said, can you start shutting down your kit? And I said, that's fine. So we opened the door of the cabin, stood in the doorway. He was like, yeah, it's working, it's working, it's working. And I was like, right, okay, I'll shut something down. So I shut something down. There's no, it stopped working. Right, so I'll turn that back on. No, it's still not working. Right, so it's not that then. So I shut down all these bits of kit, and we've got a fair bit of kit up there. I mean, we've got 2 UHF transmitters, two UHF repeaters. We've got a bank of 3 SDRs that we use for experimentation. Yeah. We've got a LoRaWAN gateway. We've got a Tetra repeater on the amateur bands, which is quite good fun. Although we haven't published that it's up there yet. We're experimenting with it. Tetra is the same system that the police use. Okay. We use it on different frequencies, obviously, but we've started experimenting with Tetra because in a few years' time there is going to be a flood of Tetra equipment come on. Second-hand
the police move off.
While they move onto the ESN, the Emergency Services Network, all that Tetra kit will be decommissioned. Yeah. I'm hoping most of it will, some of it will be sold second-hand, etc., etc. Because I was there when they decommissioned the UHF stuff. So all that went on eBay. So we've got a Tetra kit up there. So we've got a lot of stuff up there that's all humming away. We've got some recording stuff up there. We've got a couple of PCs that do remote access for us. So I'm shutting all this stuff down. I was up there for about 4 hours with Mark, and eventually I had everything turned off. And he triumphantly opened the cabin door and went, "That's it, it's fixed. We're not losing lock anymore." And he went, "Right, okay, let's have a cup of tea." And he moved out of the way. And as he moved out of the way of the cabin door, it lost lock. Yeah. I was like, "Oh, Mark, it's lost lock. What's going on?" And he said, "I really don't know." He said, "I've tried everything. We've had, because Dover Coast Guard have got some kit up there. Yeah. The Pilot Boat Service, they've got some kit up there. Right. You've got the Thames radar array up there. So there's a lot of big stuff radar transmitting. And he tried all of those guys. They'd all shut stuff there. I mean, they had the Thames radar system shut down for half a day while they were trying to figure this out. Okay. So they just shut
to sort out Margate's TV. To sort out Margate's TV. It's important, isn't it? Yeah. That's a way through what this is for. It's for Margate's telly.
Keep the masses entertained.
And most of us are still pulling their Dover.
So you would be surprised how seriously they take loss of TV, because if the masses don't get their Emmerdale, we're in big trouble.
Civil War.
Exactly. Okay. Yeah, what they say, 3 meals away from Civil War. No, it's three episodes of Emmerdale. So anyway, he's out of life. He's like, "Oh, I've done all this, and I went, "Okay, now let's have a think about this. You're opening the cabin door, everything's turned off. It's fine. When you move out of the way, it loses lock." So obviously your body is attenuating any signal that's coming. Oh, okay. So when you're in the cabin door, it doesn't lose lock. When you stand out of the way, it loses lock. If you close the cabin door, it's fine. It doesn't lose lock. Yeah. I said, "So why don't you just keep the cabin door closed?" And I thought I was being smart. And he said, "Well, the problem is we're upgrading this in a few months' time, and we're going to have the guys coming in and out. I can't just close the cabin door after every, So we need to get it fixed."
So and they haven't got a microwave oven just the outside.
It's far better than that. Well, I went and stood in the cabin door, and I was like looking at the GPS, and I was like, "Okay, so I'm where the GPS receiver is. It's not coming in through the antenna of the GPS because that's outside, so that would cause it all the time.
Yeah.
So it's got to be something coming through the door when the door's open and physically hitting the GPS receiver. It's got to be something. So I turn around and I look, GPS receiver behind me. I look line of sight. Only thing that can see the cabin door is their own antenna. And I said to Mark,
transmitting?
I said to Mark, have you turned your own transmitters off? And he went, no. I said, turn your own transmitters off. So he walked in, turned all the transmitters off, GPS locked straight away. No problem at all. Like, it's your own antenna. You want all of these guys up here, countless man hours. It's your own antenna. He went, no, tell anyone.
Oh, edit
So,
this bit. We're still recording.
Still recording?
Oh, yeah, that's fine. So the official fix was he said, well, I've got a problem. He said they won't give me a new GPS receiver.
Yeah.
Because budget constraints and stuff. And I said, okay, well, what can we do? And he said, well, I don't know. And I said, well, I've got all our gear is in racks. All their gear is in racks. And I said, I've got some front panel blanks for the rack. So I said, how about I unscrew a couple of my 2U blanks and we mount them on your rack in front of the GPS receiver? And he went, that's a blinding idea, we'll do that. So we done that, problem solved, no problem at all. Just a little bit of shielding to the front of it, no problem at all. And then so we phoned up the chief engineer and he said, right, we're all done, we fixed it, we can turn them back on. Because while we were messing around with it, they adjusted the, I guess the safeguard on it. So basically if it loses lock for more than 5 minutes, they shut down.
Yeah.
And while we were playing around with it, they adjusted those safeguards so that it would have to lose lock for an hour before it shut down, so that we could compensate by messing around with it, basically.
Yeah.
So we phoned up the chief engineer. He said, we're all done. Change it back. He said, what have you done? He said, I'll send you a picture. So we sent him a picture of these beaten up metal racks on the front of their lovely shiny equipment.
Yeah.
And the call came back fairly quickly, and the chief engineer said, it's fine. We'll ship you out a new GPS receiver. So they shipped them out a new receiver. Because they didn't want these dirty old plates, really pristine stuff. But yeah,
and the new one has better shielding, I assume.
All fixed because of that. Yeah, amazing, isn't it? But Mark was telling me, his favourite job was they fly out to, I think it's the Isle of Man they fly out to.
Yeah.
And they've got a station on the Isle of Man. Most of their transmitters are inside buildings.
Yeah.
And all the transmitters are inside climate-controlled environments because they're road and sports equipment, which is super high, it's super high level stuff. It's really expensive kit.
Yeah.
Really expensive kit. But it is also very sensitive and it doesn't like moisture.
Okay.
And he said, I can't remember which island it was, but they fly out somewhere and he usually has to spend a couple of weeks out there because it's foggy every day. And these bits of kit are so sensitive that you can't open the door to that cabin in the fog. Because the moisture going in just trips all the kit over. Why are you building equipment? Like if you breathe on it wrong, it's not working. But that's what they do. These multiplexers are so highly tuned, and so in sync, and like everything is just on a knife edge with them.
Because it gets every last bit of bandwidth out, or every little bit of information through.
Every last bit of performance out.
Someone at a conference was flogging microwave multiplexy kind of things.
Okay.
I'm going to use the terribly wrong words in. But he explained it. He told me to imagine an arm rotating around, but the amplitude of that arm changed to kind of select kind of points on the face of that dial, and each of those points was like a channel of data being sent, and his description just painted a picture in my head, and it's absolute genius. The way they multiplex so much stuff in that way, incredible.
Well, this is done. These digital radios, DMR is done by something called time division multiplex.
Multiple access. TDMA.
So what it does, it takes your radio channel of 12.5 kilohertz bandwidth, and it transmits a bit of data here, and then you have a little guard band, little guard time, and then it transmits another bit of data. And what that means is that with this digital radio, you can have two completely separate conversations on the same bandwidth of frequency that a traditional FM analog radio would use for one. So you double your capacity basically. Whereas other radios like the ICOM radios, who use a system called D-Star, That's FDMA, that's frequency division multiple access, where they take that 12.5 kilohertz and they split it into two 6.25 kilohertz streams and send your data at either one, basically. So you can have two conversations on the same amount of bandwidth, the same physical space. So in radio terms, in communication terms, it's the equivalent of taking the M25 and doubling the number of lanes on it. You know, you instantly ease congestion and free up bandwidth. So commercially, it's a massive thing, because instead of buying two, £4,000 repeaters, you only need to buy one, because one can handle double the capacity of a single hour. But the only problem with the different modes is FDMA. You're trying to squeeze all that data into a tiny amount of bandwidth, so your voice quality can be a little bit lower, and your data that you can send is a little bit slower. So TDMA, where you're splitting it by time, is better for quality, but it's rubbish for distance, because it suffers the same problem as effectively the mobile phone network, which is the laws of physics dictate how fast radio waves can travel. And the guard band is a set number of milliseconds. So if you are so far away that your signal arrives at your destination after the guard band, it just rejects it because it's out of sync. So the maximum physical range on a radio like this is about 150 miles, or 150 kilometers rather. So if you go outside of that, the time it takes for the radio wave to leave here in the correct time slot, it arrives at your destination in the wrong slot. So it just gets rejected. So you can't use radios like this over satellite links or over long distance radio links. Whereas the lower quality audio FDMA, frequency division, it doesn't matter the distance, because you're splitting the frequency in half, not any timing. And it's the same with mobile phones. You can I mean, the 4G modem that I use, I can point it at a mobile tower miles and miles and miles away, and it will connect, but I'll never get any data through it or anything, because it's so far away that the time slots are out of sync. So the data.
It's the difference between serial and parallel in a way, isn't it?
Well, actually, that's something remembering. Okay, so you remember when hard drives were the ATA connector, the parallel connector? And I remember, this was before I started learning about radio and stuff like that. And I remember, they were moving to serial ATA. And I remember, well, clearly that's got to be slower. There's fewer wires carrying signal. And it was, as someone pointed out, but the interference that you were getting, the crosstalk between all those parallel wires, to slow down the signal. They had to slow down the signal so much that they can now get to the point by using a single wire or just a couple of wires, they could run so much faster that it actually more than made up for the loss of parallel signal wires.
I didn't know that was
when they were that close, because it was a ribbon cable. There's no sort of protection or anything built into it.
That reminds me of what you were saying about we used to call them cosmic rays, the particles from outer space that affects comms, but we were worried about its effect on avionics, because the feature size of avionics chips in particular is getting so small that they're more and more and more susceptible to cosmic rays. And now that fast jets are, the avionics is safety critical. You can't fly a Typhoon without a computer. It's unstable. A human can't control it. So you need the computers. But if you fly high enough, you lose a bit of quite a lot of protection, and your computers are more and more susceptible to it. And there's not really much you can do about it, because it affects every system randomly, kind of thing.
Lots of shielding, that's it.
You can't really put lead or any kind of shielding on a fast jet. So it's
if it starts tumbling down, does it then recover?
not fast enough to help you. Really.
I worked up near Rochester Airport for a while, based up there, and there were two fun things that happened there. First thing was an Apache came in, unscheduled, and from where I was working in the office, all I saw was this Apache land. Someone jumped out, so the Apache was left running. Someone jumped out of it, so I'm guessing either the co-pilot or the gunner or something, but someone jumped out of it. Literally disappeared, came back about 5 minutes later, and then all I saw was this thing land, a guy leave, a guy come back, the helicopter take off, and then it flew up to the control tower at Rochester Airport, which is a tiny little airport, and it's grass runway, little tiny 2-story control tower. and it hovered in front of the control tower, about 5 or 6 foot, really close to the control tower, right? And on the front of it, they've got these big cannons, haven't they, on the Apache?
Yeah.
And I know that the Apache, the cannon on the Apache is linked to the gunner's headset, so wherever they are looking, the gun moves.
Oh,
So
wow.
if you look to the left, the gun moves to the left. It's an amazing bit of kit.
Yeah.
And the gun was doing this. I was like, what on earth is going on? And I saw the airport manager a couple of days later, and I said, what was the Apache doing? And he said, oh, they made an unscheduled landing. They weren't cleared to land. So we had a Cessna on approach, and we had to pull them off because the Apache just turned up unannounced. And we told them they shouldn't land, and they just came in anyway. I thought, what were they doing? He said, oh, they needed a piss. So he literally jumped out, went to the toilet, got back in. And he said, so I got on the radio and gave them a bawling out over the radio.
Yeah.
And that's when they hovered it in front of the control tower and started following around the control tower with the cannon, and they flew off, and that was it.
That's very Morsey.
I said, what are you going to do? He went, oh, I think, it's all right. He was a really cool guy. But the other cool thing that happened while I was there, and you mentioned about the typhoons, and that reminded me, is we were sitting there, and Rochester Airport is right next to BAE Systems.
Yeah.
And we had 2 typhoons come, and they circled for about 45 minutes-ish, just above BAE and above the airport, just round and round and round they went, no problem at all. Then they disappeared. And again, I spoke to the airport manager a few days later, and I said, what were they doing? And he went, they were getting a software update. So, what? And apparently they flew them over BAE, and they got an over-the-air software. The plane that can't fly without a functioning computer, because it will just fall out of the sky, got an over-the-air software. I was sitting there going, oh, they're not running Windows.
No, there's no Windows.
Amazing, yes. But there you go. So
engineering is
software
fucking
update.
awesome, isn't it?
It is really good. I'm really sorry, guys. I'm going to have to go. This has been fantastic.
Yeah, really
I should
has.
go,
Thank you.
I should go as well. Really?
Come back for another.
Yeah.
Yeah.
Yeah, I will do.
Excellent.
I will do.
Definitely talk, just doing social stuff. All right. I will catch up with you next week.
Yeah.
Yes, all right. Yeah, let's figure out working bits and stuff. And yeah. Thanks,
Awesome. Good to see you.
indulging me.
That's
Yeah.
great.
Yeah, thank you for indulging. I'll probably get this out again some point.
Also, it's brilliant. It still works after 10
I
years.
know. And we've got the visuals on
Take it home,
Trig.
fire it up.
That's it. Yes, see if I can get on trig.org.
That's
for
it,
you.
yeah. Yeah.
See you later.
Right,
Excellent.
I'm going to stop this recording now.
Yeah, super. And yeah, thanks in the chat. Been a pleasure.
Yeah, and Meat Lotion saying thank you very much too.
Super.
And see if I can figure out how to.
Get hold of me through the various links, and we'll talk about your intermediate as well.